This
What,
conference will now be recorded.
yeah, thank you. So in the last session, we have discussed about the what are the components which are present inside the worker node and what are the components which are present inside the master node. So just to recap that, uh, let me just go to the PowerPoint presentations quickly, and then I will come back to my slides as well, but to the whiteboard as well. So this is something which you have seen last time. So what is there inside the Kubernetes architecture? So we have, you can have one worker node, you can have at least two worker nodes for the high availability. Then we can have multiple, so you can have nodes, there is no limit for that as such. I have heard that you can have 500 worker nodes, you can have 1000 worker nodes inside one cluster. Uh, but what is there on the worker nodes? On the worker nodes, we have main component, that is a container engine. And on top of that, the main agent, which is very important agent, that is called as a kubelet, is residing inside the Docker worker nodes. Kubelet is the captain of this particular worker nodes. That is what we have discussed last time. Yeah. What this master node contains, please mute guys. What this master node contains, it contains the API server, which is a very important interface. So through which the developers or external entity or the external APIs talk to the Kubernetes cluster. There are controller managers such as cloud controller manager as well as the internal controller manager is there to manage the replicas or pods inside the Kubernetes cluster. And very interestingly, there is a scheduler and etcd is there. So what is the job of the scheduler? Scheduler job is to find out the healthy worker node. If any unhealthy worker node is there, it will filter out from the work cluster. It also finds out which one is the better worker node right now, who's having a more resources or enough resources to deploy, right? So this is something which is scheduler job is. So once the scheduler says that, look, the pod one looks very good, pod two, so worker one and worker two looks very good to deploy the pods, go ahead and deploy this on the worker nodes. That is the instruction will be given from the, that is the instruction which will be given from the scheduler to the API server. And then API server will, of course, it will update the etcd, and then API server will talk to the kubelets of the appropriate worker nodes. And accordingly, the pods will get deployed. So these are the two important parameters. So etcd maintains the information about all the components present inside the cluster, they're in the key and value format. Scheduler decides where to deploy the workload or payload, it is called as. Controller manager controls the pod, their replicas, their desired state, their health. If there is any unhealthy pod is there, then there is one replica set controller is there which take care of uh, creating the pod in case any pod is unhealthy in the cluster. So as well as if there is a cloud controller, the cloud controller will talk to the various parameters, various components of the cloud. So this is something about the master node, right? But what is there on the worker node? As we discussed last time, this is a kubelet. This is the main captain of the worker, which which always keep a communication with the API server and the API server, and it also take care of the all the it take care of the all the components which are residing inside that, deploying the pods. That is one of the job of the kubelet. Okay, so why do we need a Docker here then? Why do you need a container engine inside the worker node? Of course, the building block of the Kubernetes is pod, and inside the pod container is there. And to create the container inside the worker node, you need something called as container engine. So we need to have the container engine called as a Docker or any other container engine which you feel that should be better. You can use that, guys. All right. So and they, to to have a better communication, to have a communication inside the cluster from one node to another or between the master node, you need to have the CNI interface. So the job of the CNI interface will keep the all the, please mute guys, all the master as well as worker nodes in sync, and they will communicate with each other through the CNI. So what is CNI interface? We'll see that what are the different CNI interfaces are available. So C advisor is the another component which is present inside the worker node, and its job is to check out the health of each and every component, such as pods inside the worker node, see their CPU utilization and RAM utilization, and inform that to the master node. So if there is a metric server installed in the master node, that will be that information will be passed to the metric server, and so hence the monitoring will be done. So proxy is something which is interesting, which gives the IP addressing mechanism, networking mechanism for the interpod communication, as well as service abstraction for the external entity. So in case you want to access any application from the outside, so service abstraction is also done by using the kubeproxy. So in short, in layman's language, kubeproxy maintains the networking of the services or application. So service is another layer that we'll discuss in the Kubernetes networking topic in detail. Don't worry about that, guys. So this is a developer. Developer will give the information to the Kube API server, and then API server will talk to the etcd. It will update the manifest. It will take the information from the etcd as well, and then it will talk to the scheduler, and it will ask scheduler that, look, this is the manifest or YAML file, or this is the request came from the developer or administrator or any other APIs, external APIs. They're asking to deploy the pods and resources. Then as per the, after the scheduler decides on which worker node need to be resources need to be used, then it will inform to the kubelet, and kubelet will deploy the pod inside it, right, inside the worker node, and then the communication will start. So if you want a multiple copies of this particular pod, then it will be informed to the controller manager. And inside that controller manager, there is something called as a replication controller. So replication controller will check how many pods need to be deployed, what is the desired state, what is the definition written by the developer, and accordingly that many pods will get deployed in the worker nodes, respective worker nodes, and that can be accessed through the service, so which will be provided by using the kubeproxy, right, guys? So this is something which is we are going to discuss in detail. Okay, so let me delete this. So what are the components of the master node? Just now we have seen, but let me run through this particular website very quickly, presentation very quickly, guys. We have seen about this API server. So it just configures and validates data for API objects. So how many services, pods, deployments to be deployed inside the pod, that is managed by the API server. Scheduler decides where in the cluster the workload will be able to run, and etcd stores all cluster related data inside the database in the key value format. And there are the controls. These are the different controllers which will keep a track of all the pods, such as replication controller and everything, which will take care of how many replicas need to be maintained. If something goes wrong, the controller are responsible for recreating the pods again. So this is what master nodes architecture. So let me run through the worker node architecture also quickly, guys. So it has an important parameter called as a kubelet, as I already told you. So it is a primary node agent actually, which performs various tasks like mounting the volumes, creating the pods, running container, maintaining the running containers, and everything is done by using this kubelet. As I told you earlier, that kubeproxy is something which provides the service abstraction and connection forwarding, nothing but in short, networking. Right. So Docker is something everybody knows about that. It is a container engine which is used to create a containers and will be deployed that containers will be deployed inside the pod with the help of kubelet. And as we discussed earlier, what is a C advisor? It provides container users an understanding of the resources users and performance characteristics of their running containers. In short, it will check the health of it. It will check the how much CPU and RAM has been utilized uh, by the particular pod in the worker node, and that information will be passed by the C advisor. It will keep that information inside the C advisor. All right, so that is what worker node architecture is. And so basically, if you see that, guys, let me just explain that in. So look at this. So this is a developer. Developer will not be able to talk to directly to the kubelets. So if at all you want to deploy any payload or workload inside the Kubernetes cluster, only entity which is available is API server. So if you want to give any instructions, right? You want to deploy pods, or you want to deploy application, or you want to deploy service, you want to deploy persistent volumes, whatever it may be, that everything will be done by through the API server. Okay, so last time I discussed about what is a pod. I hope that everybody remembers it, but let me explain you. Pod is nothing but what? Pod is something like uh, which looks like this. This is a Kubernetes object. So pod contains the container. So you can see this, guys, right? So this is a proper definition for the pod. So you can have multiple containers, one container or multiple container inside the pod. So you can see that there is one pod you have one container, in another pod you have multiple containers. So in short, like we have seen in the Docker engine, Docker, that container is the building block right there. But in the Kubernetes, pod is the building block of it, but inside the pod, containers are there. And basically pod gets IP address, not containers. Right, so containers works on the port namespaces. That is important to understand, right? And this is something which you need to remember, that, guys, this is a structure of the Kubernetes has been defined by the Kubernetes engineers and developers, that they are using a logical entity called as a pod, and inside that they are just creating the containers of it, right? So only difference between what somebody will say that what is the need of the pod? They can directly use the container inside it, right? One container can be, because everything is a container, right? So why do we need a pod, right? But basically, if more than one container is there, then how you are going to group them? So grouping this one container or many containers, they have defined with one logical entity called as a pod. All right, guys. So that is something about the Kubernetes basic building block. So everything is a pod inside the Kubernetes container, the Kubernetes cluster. And inside the pod, please keep this in mind that it contains the containers. All right. So before moving ahead to the Kubernetes deployment, because I want to deploy the Kubernetes cluster now, if you have any questions related to the architecture, we can discuss, and then we can go for the installation of the Kubernetes. So let me see that if we have any questions. Guys, I will take the questions from the chat box, and then only, if at all, if I don't answer that question, then only you please uh, ask the questions. Okay. So Tulsiram is asking, on what basis the scheduler will schedule the pods in the cluster? Is there any process? So yes, so there are multiple processes. There is an algorithm available, and first of all, it will find out the unhealthy pods, unhealthy worker nodes, and if any unhealthy worker node is there, then the scheduler will remove it from the deployment process. And another important aspect is that called as scoring, and scoring is done best basis on the uh, resource utilization, how much CPU and RAM is available on respective worker node. Depending on that weightage, scheduler will decide which one is a good worker node to deploy right now. So I hope that it answers your question. Abhiram says that where does admin interacts in the worker? Admin interacts shown in master only. Yes, Abhiram, that is true that you can, if you want to deploy something, you have to use the API server from which you can deploy the payloads, different payloads, right? However, if you are a real administrator and if you want to fix something in the worker node as usual, because it is a Linux box, or then you can directly take access to the root and then you can log in. But as per the Kubernetes cluster, or if you want to inform or if you want to guide anything to the Kubernetes cluster, you need to talk from the API server only. Okay, so I hope that answers your question.
So Ramesh, my thought was like, in case of, so you're telling, so worker also interacts with, admin also interacts with worker when it comes to administration, correct?
Yeah, it is operating system layer. At the operating system layer, administrator can access the operating system by using administrator rights.
So
However,
go ahead. Yeah.
However, if you want to deploy anything in the Kubernetes cluster, you have to go through the API server.
It's master, and also the user interaction comes in worker only, correct?
User interaction, you mean it has through the it has be through the service layer, otherwise not.
Yeah, kube proxy. I mean, like when user means client, any client wants to access our API, that's only comes through the
See, basically how it happens. That is a good question asked, but let me just put to you across you that how it is done. So see, basically, if this is your cluster, I'm saying this is cluster. This kube proxy is not only available on the worker node, it is also available on the master node as well. So if any, and this is your, and you have three worker nodes, right? So let's say this is your master node and this is your worker node. These are the two worker nodes are there. So let me put it in this simple way. This is your master. This is your master, this is your worker node, and this is your worker 2. And this kube proxy is spread across entire cluster. It is not that only it is available only on the worker nodes. Kube proxy is also available here. Okay, and if you want to access the application which is deployed inside the Kubernetes cluster, you can use any IP address of the master, worker node, or worker 2 to access the application. So in short, users are not only, whenever you are trying to access, the outside users will be only allowed to access the Kubernetes application by using service abstraction, which is created by the kube proxy. Directly, users will not be having a direct access. They will be only able to access through the service.
But Ramesh, sorry to interrupt. I think the application will be only deployed on the worker node, right? Not on the master. Master is just to monitor how the worker is performing. So the direct interaction from the outside world will be on the worker node.
I will show you. Just you need to hold for some time. Let me deploy the Kubernetes cluster, and I will show
no
that
problem.
we can access the pod which is deployed on the worker 2 from the master node IP address also. Then I think that thought process will get clear.
So you mean to say that then I think in last class you have taken one session on Docker Swarm where like the master node can act like a worker node. So you mean to say like in this case also the master will act like a worker?
No, I am saying that I can access the application which is deployed on the worker nodes from master node's IP address also.
So, but in that case, there will be a multiple hop, right? From master to worker.
No, that is what I think.
Okay,
if you
fine.
hold
Okay,
for some
sorry.
time, I think we will be able to definitely rectify. I got your point, and that is absolutely very good
I'm
point.
sorry for that.
Yeah, not an issue, not an issue. Fine, thank you.
But on the same question, Ramesh, one thing. See, if I have a EKS, AKS, or GKE or OKS, so that master will be controlled by the vendor, right? So I don't have much. So my admin will not have work. But again, when it comes to worker, I mean, in that world, I mean, we are talking here about a Kubernetes open source enterprise version. So yeah, master we need to control. But when it comes to that world where AKS, or OK, whatever the things GKE is there,
Mhm.
the,
See,
the admin will be only responsible for worker, right? I'm just want to know that part also.
yeah, absolutely correct.
Yeah, okay.
Okay. All right, that's fine. Oh, Santosh, I hope that you got the idea of the pod now, right? Pod is nothing but it is a logical entity which holds the containers. Yeah, thank you.
Excuse me,
If you have,
Ramesh. You just
yeah.
spoke about the service and the proxy. You said when you have a service, you just gonna use the service IP address to access the application or what? Can you explain that one more time for me, please?
Okay, Polan. This question actually came across that why we need how application will be accessed from the cluster. If you have deployed the application, right, and you want to access that application, so there is one layer is there that is called as the service layer, which is spread across the Kubernetes cluster, and that service will get a IP address. Of course, it will be a we have a very good we have a very the in-depth session on that one. I will be discussing about it. So which will get some IP address, one unique IP address will be there through which we can access the application which is deployed. So service is nothing but additional networking route deployed in the Kubernetes cluster as an interaction to outside world. So if anybody, any users want to access the application, they will not be able to access the application directly. They have to go through the service. So what is the service? How it looks like? What are their types? That we'll see in the service session. Is that okay, Bolan?
Yeah, you mean you're acting like a load balancer service, or
Yeah, we have that three types are there like cluster IP, load balancer, and other things are there. But I just want to keep the discussion limited for this particular topic because
okay?
we when service topic will come, we'll discuss in detail about that one.
All right, thank you.
Yeah, please hold for some time. Yeah, Anuj, Kubernetes is deprecating the authorized container.
Ramesh, could you please explain again?
Which one? Santosh, you want me to explain again what pod? What is a pod?
No, Kubernetes architecture. And suppose if that pod contains, let's say, 3 containers, okay, and if that
Hmm.
pod fails, then what will happen with the containers? That will be also failed.
No, if the container is failed, the pod is about to fail. Pod will be failed for sure. But then there will, if it is in the deployment or if it is in the some different controller, it is controlled by the different controller managers such as replication controller. The new pod will get generated. But if it is only static pod or only one pod, it will be fail sure. I hope that
Okay,
is clear.
so yeah, means like okay, means one pod, then everything will be failed. If there are multiple pod, then that will be automatically created, right?
Right. If it is maintained by the replica sets, it will be maintained.
Hmm.
It will create the pod again.
It's kind of an auto scaling group in the AWS.
Okay, we'll discuss that one, Santosh, in detail. We'll discuss
Okay.
that in detail. Yeah.
Okay. If you don't mind, could you please explain again that Kubernetes architecture? I didn't
Uh,
understand that one.
Not an issue. You can do one thing. I will explain in latter part also. So in case, because I have explained two types in the last session also I have explained, and this session also I have explained. So I request you to please revisit to the specific and discussion. And if at all you have a specific question from the architecture, then you can ask me. Because explaining entire topic is again it will be a time consuming process. If you don't mind, Santosh. Please
It's
revisit this.
yeah, it's
Hmm.
okay. No problem. Thanks, Ramesh.
But if you have specific question about the architecture, I will be explaining that. Okay.
Sure, sure.
Thank you. Thank you for understanding. No, I think that's finished. Dan. Okay. I just want to pick up, just revise that, Dan. That's why I took it. Okay, Anand, pod size specification and container size specification, is this a manual calculation by Docker admins, or is there any feature to manage size management and well-planned pod container configuration? What is the actual question, Anand? Anuj, I will come back to your question, but Anand, I just
Yeah,
not
the
able
question was
to
really
check that.
about the size of the pod, within the worker nodes and the containers within the pods, based on the application requirement. How the sizes are allocated, resource management. Um, uh,
Yes, yes, yes. I got it now. You are specifically asking about the capacity planning of the pods inside the application, right? So, right. So how much CPU and RAM should be assigned, and when to assign, and where to assign, right? Is
correct.
that your question? Yeah, good. So,
That's
so
correct.
we'll see. Yeah, we'll see that in our resource allocation discussion, and we'll spend a lot of time on that one. But
Okay,
precisely before deploying in the production, we'll be doing a lot of testing, and then when we come to the conclusion that this will require this much CPU and RAM. Okay.
sure. Thank you.
Do we create the containers in pods or pod? What is the question? Yeah, guys, it is going. Dan was asking some question. Do we create the containers then pods, or pods then containers, or either way? See, basically, to create a pod, you need a container. So first of all, container need to be created, and that is the job of the Docker engine, which is or container engine, which is inside the worker node. All right, and then pod will be created. So it is not either way; it is only one way: container and then pod.
Oh, thank you.
All right, Dan. How do I design the master and a worker when it comes to cluster with multiple zones? Abhiram, this is something which is related to cluster upgradation, cluster automation, or in case something goes wrong with the one cluster, how my another cluster will take care of it, right? That is what your question is. How do I design the
Yeah,
master?
basically my question was, Ramesh, like now you are telling one master and multiple worker, that's fine. But when it comes to multiple regions, say US East or US, I have US East and US West. Do I manage with single master on having worker on US East, multiple and US West, or I have a master here and there? Or so that, I mean, I really want to know details of it, not
Yeah,
only
sure.
towards failure, but also the designing part of it, because we are discussing on design. So I was not sure whether one master can hold all 100 region. I don't know. Or if I need to cluster master, I mean, or I don't know. Yeah, that part I was, not clear. Yeah.
See, basically, it is very important to have the high availability of the master nodes. You should not run
Correct.
with entire cluster with the one master node, right? So how to do that, that we'll see. But you can have the master nodes if you have a proper peering created. So it is very important. You can see, after all, it is something which is, if you are deploying the EKS or AKS, that master node, multi-master node concept has been taken care by them. But if you are doing it on premises, okay, then the concept is different. But if you are using AWS or EKS and you are trying to create your own different master servers in the different zones, right, then you should have the proper VPC connectivity across the master nodes. Then only it is possible. Otherwise, it is not possible.
Yeah, no, what my question was, Ramesh, do we have any diagram which can say, okay, this is how it is? So I don't want to create it, but I want to understand it, because that's what
Yeah.
I'm not able to visualize.
Oh, so we have one session on that one. I will definitely take that. Don't worry about it.
Oh, okay.
Ramesh,
Okay, fine.
Ramesh, sorry to interrupt. Okay, what we are discussing is Kubernetes architecture of master node and worker node. Many people are asking questions for the future topics. Okay,
Yes, right.
okay, that is not relevant. Okay, let's ask about the current architecture. We have not started installing the KubeADM or configuring the master node or worker node. What is
Yeah,
pod? What is
yeah,
deployment? Nothing, right? So
Yes,
there
yes.
are many people, okay, layman's are there. The people who are having already understand, right? They are going in advanced way, okay?
All
Which
right, all
is
right.
irrelevant, right? I mean,
Yeah.
just telling. I hope you also agree with that.
So that's fine.
No,
See,
the question here is, Ranjit, 1 minute. The question here is when you talk about architecture, it's about architecture. Architecture can go anyway, right? So to answer your question, it can go anyway. I mean, let's not stop here. But if you're telling about anything specific, we'll discuss that. But my thought is,
Correct.
if you talk
Yeah,
about
yeah.
this is what is no, Ramesh talking. No, don't hold on it. Ramesh talk is this is what is architecture. We'll go for lab. When we talk about
Exactly.
architecture, you need to talk about it, right? So you need to
Yeah,
tell me that
architecture is
whether
different.
architecture is going
Communication is
to.
different,
Oh,
right?
no.
guys,
Hold on.
can you hold on?
I was listening to you.
Can you hold
Ramesh,
on?
wait.
Sorry,
So,
You
guys,
speak.
I think
sorry.
guys,
Please,
you got to act like a adult
yes,
here. And
hold
then
on,
the
hold on.
Ranjit says a point, and please accept it. Let's move on. Let's not discuss further.
Okay.
Yeah, exactly. So we have to learn
Hello,
alphabet
Ranjit,
Kubernetes, right?
your point is listened, as well as I have heard about his point also. Whatever
Correct.
the answer I need to give, I will give it to appropriate
Correct.
discussion.
Correct.
Please hold
Alpha
on
also
for
sent a voice message in the WhatsApp. So
everybody.
let's learn it slowly. Let's learn it slowly. We
Yeah,
have
everybody
various.
respected here. Yeah, everybody's question will be respected here. Don't worry about that one. Okay. So guys, let's move ahead.
Ramesh, I have a question. Okay.
Mhm.
You said in case of a pod, right? Pod is nothing but a logical grouping of containers. Okay.
Mhm.
So the pods will have IP address, not the containers, right?
Mhm.
But then earlier we have seen that containers do have IP addresses, right?
Right.
But here the concept changed,
Yes.
right? Right.
Concept.
So yeah. So all the containers which belongs to a particular pod, they'll be having the same IP address, which is nothing but the pod IP address.
Right.
Right. Okay.
Right. And it.
One more thing. Yeah,
Mhm.
please. Sorry.
So pod will talk to the inside the container on the port basis in case it has to be talked, or you if you want to access any container, basically it will be port level communication. Yeah, go ahead.
Okay. So, so my question is, I mean, can you give us few, useful cases? Okay, why they have designed like that? Why? Because ultimately the whole work is going to be done in a container. Okay, why we need pod? Some useful, cases so that we can understand. Yes, that's why we need pod.
Okay, no problem. I will explain you that one. I will definitely help you to understand that once I complete the architectural explanation and deployment, if you don't mind.
Sure,
Because
Ramesh.
I want
Thank
to
you.
show you practically what is the need of it. So
Sure.
that
Thank you.
gives a better understanding. Thank you.
Yeah. Okay.
Ramesh, I have asked one question. Can you just reply? I just want to know how pod to pod communication will happen. Is it like the same via IP or is it a different way?
So there is a networking concept inside this one, pod to pod communication. IP will be there. Yes, it is IP based. And basically, if one from the one application to another application, if you're talking, it will be definitely through the cluster IP address or service IP address. That we'll discuss in detail.
Okay. Thank you, Ramesh.
Yeah. Guys, all right. So, Padmasri is asking, could you please explain how we can use K8s to deploy the AWS resources every 90 days, which is compliant with we have to follow? Okay, if this is a specific question related to your requirement, we'll discuss about that later one. If there is a question about the architecture, we can take it now. Does each worker node have their separate IP address? Yes, worker node has their separate IP addresses. Yes, Abu. How many master nodes are ideally recommended for high availability and how that is alternate number, odd numbers are always good, Anush. So I have seen in the EKS and AKS cluster, as they are providing enterprise level solution, I have seen three master nodes.
Thank you. Ramesh, will you be taking us one of those labs where you will create 2 master nodes?
So that is at the end of this Kubernetes sessions. There is one nodes are there that I will take in that case required. We'll see that one.
All right. Okay. Thank you.
at the end of the course. Yeah,
Sure.
I will be very happy to do that one.
Thanks.
Okay.
Yeah.
Yeah, but only time and everything should permit.
Yeah.
Okay, thank you. And pod-to-pod communication in a worker node is possible via IP. Correct. That is Ramesh. You have asked it. Correct question. That is yes. But we will cover that later on. Capacity planning based on TPS for admin to size the cluster. Abhiram, correct. We have to test a lot of things over there. Can we deploy Kubernetes cluster in public and private subnets today, which is realistic? Tulsiram is asking that question. I need to create that one, but for the layman's understanding, Tulsiram, we need to hold for this one. Once everybody is understanding that level, then we can easily do that as well. Because I need to, then we have to create a different VPC, different subnets, routing, internet gateways, and everything will be there. So I don't want to go into the AWS cluster networking, Tulsiram, please. You try to understand that. Yes, Rajsekhar, it is multi-master is there in the AKS and EKS, as I told you. How do we assign design IP addresses to given number of pod? We don't have to do that one, but if at all you want to do that one, then we can do the networking. We can create a networking concept there. While defining the Kubernetes administrator, we can define the pod IP addresses also, what range IP addresses you want. Can we create master node on Ramesh? I hope that is clear. I have asked one question related to etcd designing in last session. So if it is related to designing, Ramesh, can you ask that question in case you want to ask it again?
Yeah, means like as we have taken the session last week about explaining the Kubernetes architecture in which HCD was a major part. So it's a backend system, we can say, right? So my question was like, in case if you want to have our own backend system like MySQL or any MariaDB, how we can design it, like if you want to use it. So you told that you're going to refer and tell me. Yeah, sorry.
Yeah, but I will tell you one thing. At the end of the Kubernetes course program, now we are going to see how to take the etcd backup and everything. In that session, we will probably will discuss more about that one, if you don't mind, right? Because
thank you. No problem.
Thank you. But definitely we'll discuss. That is a good point to take. Can we create master node on one cloud and worker nodes on another cloud? Amrik Singh, everything is possible in this world. Only thing is that you should have a networking in properly. If one master node from one part of the, forget about the cloud. If you have one office in your, let's say in the Australia, one office is there, master node is in the Australia, another office is in the United States, third office is in India. And if you have worker node at one place, master node at another master node at another place, and worker node at another places, everything is possible. Only thing is that networking should happen, and think about the latency as well. Okay, so that is possible. If networking is there, everything is possible. But latency will create a big problem in that case. So it is not advisable. All right, thank you for listening, guys. Thank you very much for asking questions on this one. Let me go ahead and deploy this architecture on the Azure. And then once we start practically, everybody will like it. Everybody will enjoy the fun of this creating of pods and deployments and workloads and everything on this Azure on the Kubernetes cluster. So guys, let's enjoy this session. So I have this master node. So basically what we are going to do now, so you can monitor what I am doing right now here. You have a recording, guys. You can watch this recording also. And if you can catch up my speed without asking any questions, it will be great, right? So
sorry, Ramesh, one thing, in the previous session you talked about links hyphen. I was thinking we will start from there, but we have lost that part also. Just to remind you, that's it. We can pick up anytime that topic.
Okay, thank you. You are talking about the Docker link, which we missed, right?
Yeah.
Okay,
yeah,
thank you.
Thank you.
Yeah, thank you very much. Thank you very much, guys. So guys, I have 3 nodes here. Yes, this is on the Azure, and on the Azure we have created 3 machines. You can see I have not deployed anything. We have just created the 3 machines. And if you want to know how to create the 3 machines on the Azure machine, I think there is one presentation created already. There is a recorded nice video on that one. You can refer that one. So I have just created these 3 machines for you guys. They are nothing having inside it, right? So let me now deploy that. So we are creating it from the scratch, guys. So what you need to do first of all, name your machines properly. So naming the machines is done by using the command called as hostnamectl set hyphen hostname. I'm going to create something called as a master, right? This is master. And if I do this one, a bash command, I see that I got a new name. This is master. Okay, already it was given, but just for I wanted to show you how to set up the node, because otherwise what happens, the big names comes in the cluster definition. When you fire some command, big name comes. So please, to avoid that, set up the host name. If you don't set up this host name, nothing will happen, but only problem is that the nomenclature gets changed. So I have another machine called as worker1 here, and I'm also going to set up the same here, hostnamectl. I will spend some time on this one, guys, for your this is my worker1. This is bash. So now you can see this is worker1. There is a worker2, hostnamectl set hyphen hostname. This is worker2. So again, this hostname has been set up properly. So I have 3 machines, and I have just named them properly. Okay, cool. Now, once this is done, the next thing that you need to do is very important, that disable a firewall. Somebody will say that why you are disabling the firewall. The guys, what is the lot of ports need to be opened in case we want to protect this particular cluster from the external access. Right now we are just learning. We are in the phase of learning.
So
Okay.
I have one question here. Like, if it's a cloud mission, why you're disabling firewall on the server?
Firewall in the sense, I'm not disabling the firewall on the server right now. I'm just explaining you this concept that it is very important. And sometime we have to check whether this UFW status, because this is very important, right? On the cloud basis, on the cloud servers, on the AWS and other, I have seen the machines which comes along with the firewall disabled. No SELinux is available, but it is very important to check it, because if you have habit that one, replicate it if you are trying to do that on your local machine. So UFW, you know that, guys, it is a Ubuntu firewall. So I have deployed the let's say this is a firewall. This is a Kubernetes cluster I have deployed here, Kubernetes master worker1 and worker2 in my machine laptop. If anybody is trying to do that one, this will be helpful steps to you guys. So please try to understand. So now another step is that now in the Ubuntu, SELinux doesn't come, but if at all you are using a Red Hat, CentOS, all these operating system, guys, SELinux by default come in the enforcing mode. So if you are not aware about the SELinux, or if you are not aware of the firewall, it is recommended in the learning stage, you disable them and then work. And once you start deploying in the production, then slowly you can think about, oh, these many ports are required, that port is required, and then you can open that many ports required for the cluster deployment. So this is 2 important things. Third
Have
important
you disabled
thing,
the firewall from here through command or from Azure portal?
no, from, if at all, if you have the machine, this Linux machine is there, and if the firewall is on, disable it. Okay. Now now let me complete this, guys, please, if you don't mind. And there are 3 nodes. Master node is there. So minimum requirement for capacity requirement is the 2 cores and 2 GB RAM. This is enough for master node. For one worker1 node, worker1, let's have 1 core is enough and 1 GB RAM. Then worker2 is also same thing. So this is a minimum requirement for the cluster to deploy. If you have better configuration than this one, that is fine, not an issue. Now, another important thing is that you have to swap off, right? Please opt the swap on all 3 machines, or how many worker nodes you are going to use in that all that machines. You need to make sure that you opt the swap. That is important. So how do we do that? How do we do is swap off? So the command is normal command is swap off -a. This is the command that you need to use. And another important thing is that you have to go to the etc fstab file. I'm not opening that file, guys, and comment fstab line, swap line, and then fire a command called as a swap off -a. Then it will get disabled. So these 3 things are important. Disable the firewall in case you are working on any other machines on-premises on-premises infrastructure for the learning phase. SE Linux, disable the SE Linux on the Red Hat, or if it is in the enforcing mode while learning. It is not recommended to switch off it in the production boxes, guys. Please please comment out the swap, so that swap is not enabled. Swap is something which is a additional memory which holds the silent processes or sleeping processes in the RAM. It is moved to the swap for the better performance of the RAM. But here in case we have to make that off now. And once this is done, then what we are going to do, guys? Then we are going to deploy the packages. Deploy packages. So what is the first package that you will deploy? The first thing that we required is installation of the Docker containers, Docker engine. So I'm going to install the Docker engine here. apt install. So my machine is Ubuntu, guys. This is an Ubuntu machine. And if you want to see what is the version I am using, you can also use the same version in case you want. This is 18.04, or you can use also a recent version of the Ubuntu. There is no problem, guys. And now if I want to install, so first of all, make sure that you fire a command called as apt update -y. So it is important to update this one, so that it will update the existing repositories and everything. And then you have to install. So I have a habit of Red Hat, guys, so that's why yum command comes frequently. So apt install Docker. I have a habit of doing this when I let it pick up the recent version or whatever the version you want to pick up. If you want to deploy a specific version of the Docker on the your master node or worker nodes, you can follow the Kubernetes link, Docker link. They have given the steps to deploy the specific version of it. But here we are using the advanced recent one. So it is deploying. So let me deploy on simultaneously on all the nodes. apt update -y. As well as let me update on my worker 2. Okay, friends, so it is now happening. So let me now install the Docker engine on all the nodes. Similarly here also, I'm starting it simultaneously so that we can finish it quickly and you can start working on it rather than waiting for one machine to complete. So it takes some little bit time. So now it is going on. Once the Docker is installed, then we'll have a repository created for the Kubernetes. Guys, it is, you can definitely first, when you are learning first time, I will suggest you to do this, go this way only. You should understand how to bootstrap the kubeadmin, how to bootstrap the cluster. Once you understand these steps, then using the Azure cluster or their own cluster or EKS cluster or AWS cluster or your Elastic cluster in the AWS will be easy. But if you don't understand the initially how to deploy it by how to deploy each and every step, it will be difficult to understand. So try to go step by step. So I have deployed my Docker on these 3 machines. Once you deploy the Docker, it is very essential to enable it and start the daemon. So how do we start the daemon, guys? How do we enable the daemon? We can use systemctl enable Docker, and you can use command systemctl start Docker. Right, so now this is done, and you can check whether the Docker is ready or not. Otherwise, later on it will fail. Systemctl status Docker. If Docker is not enabled and if Docker is not running, your kubeadmin server will fail. So let me do it on the same machine here, systemctl worker node as well. I am enabling the Docker. Systemctl start Docker. And you can check the status as well. And it should be running. Yes, it is running, active and running, guys. And I have one more machine, systemctl enable Docker, systemctl start Docker, and check the status of the Docker. Systemctl status Docker. Yeah, it's running, guys. It is active and running. So in my all 3 nodes, this is running fantastically. Okay, good. Now once this is done, then 3 important things are required for the Kubernetes cluster to deploy, and they are: one is kubeadm, then another thing is required is kubelet, and third thing is required is a kubectl. These 3 commands need to be deployed. So kubeadm command is used to administrate the cluster. So if you want to deploy the cluster, this is important command. Kubelet is required on the worker nodes precisely because API server will talk to the kubelet. And kubectl command is required on the master node, right? Specifically on the master node, you need a kubectl command. But for the simplicity, I deploy everything on all machines, but kubectl is actually not required. Kubelet is required on the master worker node as well, but kubeadm is required on all 3 machines. So how to deploy? That is our next thing, how to deploy this kubelet. So let me just give you the commands right now, whatever I have fired, so that if anybody is trying to do along with me, it will be useful for them. Okay, now once this is done, guys, then let's go ahead and first of all have the repositories created. So this is a repository required for the Kubernetes. I'm just copying this one. This is basically
Ramesh, in exam, how do we remember all this package names and all? Like whatever you're copying right now?
No, this is available. Everything is available on the net. This has taken from the kubeadm kubernetes.io file. This one.
Documentation. Okay.
Yeah, documentation. Okay. It is available. Okay, I will show you that. Just give me some time. Okay. Now, these are
What
the
are these
system
commands for?
Yeah. So these commands which I have fired now, you can see this is the command which is nothing but a bridge net filter. So bridge net filter is used for at the IP table level. So, okay, so there will be different pods get created or containers get created, right? And containers need some bridge net filter so that there won't be any communication between the containers. And so normally the pod contains the containers, and that pods are communicating with each other on all the nodes. So make sure that they are talking to each other. And this another thing that we have done is that this is for the forwarding the traffic from one machine to another machine. If it is IPv4 or if it is IPv6, and if it is all the traffic can be forwarded from one worker node to another worker node, or from master node to worker nodes as well. So to enable that routing mechanism, we have to use this system kernel level parameter. These are the all kernel level parameters which you have passed, right? And to populate this kernel level parameter, we have to use the systemctl -- system command. So now it will come into the RAM. It can be useful. Now, once this is done, then we have to use this command for transport HTTP and others, which are required for the API server while installation. So I'm doing it on my master node, then I will go for the worker node as well. This is the key required for the repository. So guys, where are these packages? All these packages are there on the Google repository, right? And when you deploy that, we need a key to check integrity of the downloading file and downloaded file. And for that purpose, these keys are very important. So we need to enable, if these keys are not there, then it will not allow you to download. That is very important. And this is a Kubernetes repository. So let me enable these repositories. So when we enable the repository, actually what is happening, whenever now I try to install apt install kubeadm command, then this Kubernetes repository will be used to download the packages from the Google repository and install in this machine. That's why repository is important. Without repository, we cannot get the packages. So I have just done that. And now let me install this kubeadm and kubelet commands. So it is started now. So I need to update it, right? apt update -y. So once it is updated, so new repository will come into picture, and now it will pick up the packages. So these packages are getting deployed on the master node.
Ramesh, on RHEL, can we place all this in the yum repo and install?
Yes.
It is the same repository, right?
Correct. I have the RHEL documentation also. If you want, I can give it to you later on. I will upload in the portal. I will give it to the Piyush and they will do it.
Thanks, Ramesh. Thank you so much.
Okay, no problem. Welcome. And so while the things are unpacking on this machine, kubeadm and kubectl, guys, yeah, it is done. So once this is done, then it is very important to fire this command, which it is something like start the kubelet, stop the kubelet. So in the Ubuntu, you can use this command, apt mark, and this command will automatically start everything, right? So you can see here systemctl status kubelet, whether it is working or not. It is loaded, but it is not active, right? So now let me start it. Let me check the status of it. So it is loaded now. Another one I want to see, that is what is the status of kubeadm. So this is basically command. It is not a service. And kubectl is also a command. But kubelet is the service which need to be loaded. And right now it is showing in the activating mode. Slowly it will get activated. Okay, so this is done now, guys. So once this is done, then we can launch the cluster. But before that, let me finish the steps on the worker node as well as both worker nodes. So quickly I will finish that, guys. So let me go here and just copy this and paste it on the worker 1 and worker 2. As well as worker 2. Okay, then once this is done, then again I need to
is
update.
and comparable with any others. those people are already in the leadership position with just 8-9 years of experience in business analysis. So this is an opportunity, and this definitely gives a lot of opportunity.
So already I have done it. Nothing need to be done on the worker. This is worker 1. Okay, so the same steps are I am following on the worker 1 and worker 2, guys. So let me give this command to you. Whatever the commands I have fired till now, use these commands, guys. Let me give this in the chat box. Same commands you can use. Okay.
One thing here, Ramesh, I don't think you started the kubeadm.
kubeadm is a command. No need to start it.
Okay.
Yeah. kubectl and kubeadm is both of them are commands. Only we need to focus on the kubelet and Docker. If both services are not running, then cluster doesn't form. So kubectl status Docker, it is running on this machine. I'm so sorry. I have very bad habits of mixing the commands. Systemctl status Docker, so it is running. And systemctl status kubelet, it is not yet uploaded, so I need to use this one. I need to deploy that. Just now I have updated the system. Okay, now
Ramesh, we have a request from everyone to go a little bit slowly.
Yeah, sure.
Yeah.
Sure. So now we have updated the system. Now let me go here on worker nodes and enable the repository. So I have copied this one and worker 1. So there is repository is enabled, and here also repository is enabled. Now I need to add the repository. So it is already done on the master server. This is my worker 1. We are adding Google repository link here on the worker 2 also. It is done, guys. Once this is done, then guys, we need to fire update command on the worker 1 and worker 2 again. So it will populate the newly created repository. Once this is done, then we have to install the commands. We have to install the kubelet, kubeadm, and kubectl. This is worker 1. This is worker 2. Okay, guys. And now I can fire this command if required. Otherwise, I can just write a command called as systemctl enable, and let me go here. It is still downloading, still updating the system. So 3 sections are there in the installation. First section is that have a SE Linux disable during the learning phase, not in the production. Disable the firewall, disable the swap. Okay, and once that is done, install the Docker. That is done, then enable the system parameters. Once the system parameters are done, then you can install this relevant packages required for the Kubernetes cluster, which are kubeadm, kubectl, and kubectl, kubelet. This is adding the repository keys. This is actually adding the repository link. Unless and until we don't do this, this will not get installed. This is the Ubuntu command to enable the commands. If you are using other Linux commands, you can use something called a systemctl enable. That is another way of doing that command, guys. So what I'm doing, if you don't use this command, guys, if it is confusing you, rather than just use command systemctl enable docker, systemctl start docker, systemctl status docker. Similarly for kubelet, systemctl enable kubelet, systemctl start kubelet, this different flavors of the operating systems are using different commands, so that is the only thing. But if you want to use unique commands across all the SUSE Linux, Ubuntu, Red Hat, CentOS, anywhere, you can use this command, guys.
Ramesh, kubelet, kubeadm, and kubectl, all three are services, right?
No. So kubeadm and kubectl is a command, and kubelet and Docker is a service.
Okay.
Yeah.
Thank you.
So all the steps has been done on the all three nodes. Let me verify. Systemctl status Docker, it is running. Systemctl status kubelet, it is still activating. That is fine, not an issue. It will get activated. Worker 1, systemctl status Docker, it is running. Systemctl status kubelet. This is actually important on this one, and on this machine it will get loaded in some time. Similarly, we have to check the systemctl status command on the worker 2 as well, right, guys? And it is activating, and that is fine. Now once these steps are done, then you don't have to do anything on the worker 1 and worker 2 for some time. So let me minimize this. Whatever I want to do, I want to do it on the master server. So what are the commands I have fired? I hope that is clear to everyone. Now let me initiate the cluster. Let me bootstrap the cluster by using the kubeadm command. It is very important that if you are doing it on the on-premises server, my dear friends, make sure that internet is running on your server, on the host machine, master, worker 1 and worker 2. If it is on the, because the command which we are going to fire now, kubeadm init, this is going to pull a lot of images from the internet, from the Kubernetes repository, and then it is going to download on your master node. That's why this command is very, very important. I'm going to show you one command, but that I'm not going to execute right away. The reason is that, look at this command, guys. Kubeadm init. It is asking you that if you have multiple LAN cards in your master node, which LAN card's IP address you want to populate as a Kubernetes cluster's IP address. If you have only one LAN card, in such case, then you don't have to use this command, then it will take a default LAN card. But if you have, let me repeat this again. In your master node, if you have multiple LAN cards, so these multiple LAN cards will have multiple IP addresses, different IP addresses will be there. So to avoid the confusion, which IP address you want to choose for Kubernetes cluster, you can use that IP address, otherwise not required. In case you want specific pod network CIDR to be deployed, maybe in the range of 10 or maybe in the range of 11.0 or maybe in the range of whatever your favorite IP addresses are, you can use this pod CIDR network while bootstrapping the Kubernetes cluster. These are the three important things that guys you need to remember. So right now, what I'm going to do.
Sorry, Ramesh, can you just please explain once again? Sorry for that.
If you have a 3 LAN cards, make sure that you use appropriate IP address to bootstrap it. Otherwise, it will take a default one, and later on you'll find that, oh, I have used the wrong IP address to initiate the cluster. Right? So
How
do
to
not
find the number of LAN cards? Sorry.
Ramesh, one doubt. Is there any specific subnet or anything you need to define for the pod network? I mean, or can we use the same production network for pod as well as KubeADM, the API server?
Okay. So guys, let me repeat it again one more time for everybody's understanding. Please mute. In case you want your pod network to be in the certain range, you can use this one. Otherwise, you can ignore. It will take a default subnet. This one. This API server advertises nothing but
okay,
right? And API server advertise address is equal to is nothing but this is the IP address which you want to choose on the master node as your communication address as a with the Kubernetes cluster. Even in case you have multiple IP addresses. How to check the multiple IP addresses? You can check this IP address show command. You'll come to know that I have only one LAN card right now, that is called as E0. This is my loop back, so I will ignore this. This is my Docker, so it will ignore. So I don't have to use this API server advertisement. I don't want to use pod network also. Let it take a default one. So I'm going to use only kubeadm init command here. Let me copy and just fire. If everything is fine, it will work.
Ramesh, one more doubt. Is there any recommendation say that we should use separate port network and the Docker, the API server in a different subnet? Something? Is there any recommendation, or we can use it the default subnet?
Okay.
What is the best practice? I mean,
I will just explain that. Just hold on for some time, please. You don't have an option to choose the subnet for the API server. Whatever the IP address you have chosen for the master server or worker node subnets, you have to use that one. There is no option. So once the IP address of the worker node is defined, once our IP address of the master node is defined, because they are in the same subnet, you cannot keep the worker node and master node in the different subnet. They should talk to each other. But for the pod, you can use any one. /16 will be okay if you have thousands of containers. If you are going to launch, it is better to use /16 subnet for the pod CIDR. Now see this, read this carefully, guys. While it is happening, while this is coming up, look. This is actually creating a static pod called as a kube API server. We were discussing, right, architecture, API server, controller manager, kube scheduler. Guys, all these are the pods. So kubeadm init command downloads all the images and it starts creating the pods, and it is now you'll be seeing these pods there. Kube API server, you'll be able to see the kube scheduler server, you'll be able to see the kube proxy pod. All these are the pods, nothing else. You can see now this is also important to understand. It generates certificates for your Kubernetes cluster. Later on, we have a in detail discussion about this one, guys. I will be discussing about that. But while deploying these Kubernetes kubeadm cluster itself, while using this one, it creates the certificates. It creates the front proxy. It creates the CA certificate. It creates the lot of stuff, guys. It creates the etcd peer. It creates the health checker client, and as well as it creates the pods. You can see a lot of things are happening here. And once this is done, it's done, right? Can you see this is the important command which we need to fire on the. So let me take it on my notepad, because if I forget, then again I need to generate it. How to generate that also I will tell you. So this is a command which need to be fired on my worker nodes. But before that it's very important. Now guys, kubeadm has been installed, cluster has been deployed. I want to check it whether it is deployed or not. It will give error, but what error it is giving here? So kubectl command is already deployed. So I am firing one command called as a kubectl get nodes. And look at this, it is giving me error. This is throwing one error. Why? Because for root user, we don't have the rights to access to the Kubernetes cluster. We don't have a rights to access to the Kubernetes cluster. So where are the rights? In which file these rights are there? These rights are there in this folder. Okay. Now what I will do, I will create one folder inside the home directory of this root user, mkdir.kube, and going to copy etc kubernetes file inside this .kube folder and renaming it as config. These steps are available here, guys. In case you don't want to do this manually, you can follow these steps. If you don't want to follow this, you can use this one. But if you are going to use this one, then you need to, every time you need to export, or you need to add this into profile file of the user. And if you are not sure about that, how to add, and that's fine, guys. This is the Linux commands. If you are not comfortable, that's fine, no problem. Just create one directory, copy the admin.conf file inside this one. If you don't understand this also, just copy, right click on these three commands, just copy this command and right click, your job will be done.
Ramesh, in that step, it has mentioned is that you need to run the following as a regular user. So, but I think here we are run as a root user. So does that any difference?
Yeah, it
Remove
doesn't. Root
sudo if you don't using a normal user, then you run sudo. If you are root, then there is no need to run sudo.
So another aspect, very important aspect to understand that, guys, we will discuss about the accessing the cluster. For accessing the cluster, root or any other user doesn't matter. It can be any user. Only thing is that when you are firing the command from the normal user, you have to use a sudo. That is the only difference. Otherwise, even if you are a root here and you have a more privileges on the operating system layer, but this user doesn't have the privileges on the Kubernetes cluster. Please make this understanding clear. While firing the command, you don't have to use the sudo. That is one thing. If you are using the root, that is the privileges. But if you are a root user, that doesn't mean you have all privileges to access the Kubernetes cluster. No. It is also a normal user for the Kubernetes cluster. Guys, that's it. And now let me see the error which was coming earlier. This error, whether it has gone or not. kubectl get nodes. This command just lists all the nodes which are present in the cluster, including master node as well as worker nodes. Good. My master node is ready now, but status is not ready. It is called as a control plane. It is running since 4 minutes and 34 seconds. And this is the version, recent version, which got deployed. How I can join
Hey
my
Ramesh, you
worker
don't need to run
node?
a ch own command.
Because I am using the root user, no need to do that. Okay. So now how I can join this worker nodes to this master node? That is important step to understand. So to do that one, we got this command kubeadm join. Just copy this, go to the worker one and press enter. So here also internet should be running because it is downloading some images. It is starting some containers. Now it is starting kubelet. And now if you see here systemctl status kubelet, it should be now activated. Yes. So unless and until you don't join, you just don't fire the kubelet command, sorry, join command, kubelet will not come into the service. So that's why I was showing you these commands multiple times. And now here also I am just firing that command. Earlier it was just in the activating stage, kubelet. Now once this is completed, you see here, it is active and running. So captain of the engine, captain of the ship is ready to roar, right? It is ready to deploy the packet, deploy the workload which is coming from the API server inside the worker nodes. Now, before bringing something into the ready state, now check out here kubectl get nodes. So my worker nodes are joined to the cluster, but they are not in ready state. Why they are not in ready state? There is a different reason for that one. But let me show you what are the images has been got downloaded here. So how to find out the images command? Docker images. This has just got downloaded, guys. Kube proxy, Kube API server, all these images has got downloaded. And not only this one, it has created the container also. How do we check that? Docker PS. You can see that it has created these containers as well. I'm not saying pod, it has created the container as well. And now these containers are being deployed in the pod. And to check that, you can use command kubectl get pods from all namespaces. What is the namespace and everything, you'll see that. These are the pods which are running. Inside pod, inside these pods, these containers are running. And inside these containers, these images are running. And now, if you go to the, if you remember the architecture diagram of the this one, right, Kubernetes, you see that we were saying that there is a Kube API server. We were saying that there is a controller. We were saying there is a Kube proxy. We were saying that there is a Kube scheduler. There is a DNS also. There is etcd master also. All has been deployed. So is the pod available in the worker one? You can see Docker images. There are two images there. Docker pods, sorry, not pod, Docker PS. There are a couple of containers running. Can I see that there are pods running inside that? Do I need to check from this place? Not required. How to check it from the central place called as kubectl command. So I can use this command kubectl get pods -o all namespace. And if you see this, if you just fire -o wide, it will give all the information on which worker node all these pods are running. So it shows that kubeproxy is running on worker 1, kubeproxy is running on the master node, kubeproxy is running on the worker 2. Now I don't have to go there and check it whether it is running or not. It is showing from this place. So this is my central dashboard from the master node where I can see what is there on the worker nodes. You have to observe the two things here importantly, guys. One is kubectl gate nodes. They are not in ready state as of now. And there are two pods which are showing in the pending states. They are DNS related. Now, to bring all the system into why they are not in ready state, because to connect all these three, to have a network communication between all worker node as well as master node, some parameter is missing, and that is called as CNI interface. CNI stands for container network interface, and that is missing, and we need to deploy that. Once we deploy that, then our DNS will also come up, and as well as this will be into ready state. So what is the command which is used to integrate all these three components or all the master nodes and worker nodes together so that they will come into the ready state? That is CNI interface, and I'm going to use View Network, View plugin, View CNI plugin. That is a View plugin to integrate this one. So how do I do that? So I have one command called as a kubectl apply. So I'm just using this command, guys, to deploy the plugin, and you can see this is available on this Kubernetes cluster, Kubernetes documentation. All the steps which you see here, all of them are available in the Kubernetes documentation. It is taken from that page only. It is nobody has created from anywhere. Yes, now it is getting applied. I need to just deploy on the master server and not on the worker nodes. And now if you see here, you will start seeing that kubectl get node command. In some time, this will start coming into a ready state quickly. So what happens
Ramesh,
when I deploy?
so you are using Wave works, right? Instead of that, we can use Calico, other CNI also.
You can use that also. You can use Calico, you can use Flannel, you can use View. Plenty of the CNI interfaces are there.
Okay, thank you.
Can you see now it is in the ready state? My cluster is ready. Look at the pods which were in the not running state earlier, little bit earlier. There was a DNS issue. It has also been solved. It is in the running state. Okay, so these are the steps that you need to follow, guys. How to check whether this View network is installed or not? This is a simple command: get pods -- all, or you can use -- all namespaces. This command will show that whether View network is started or not. So this is the pods are there which are got deployed, and there are two pods are there. Basically, there are 6 total pods, you can say. Then they are working on all the worker nodes. So see here, this View network is also available on worker 1, worker 2, and master.
Ramesh, so you said DNS issue is resolved by installing View plugin, right? So what is DNS issue? So I mean, sorry for the basic questions and all. So yeah.
Okay. Just give me. Yeah, I'll just try to answer it. Just give me 1 minute. So guys, our network, this particular stuff has been completed. Steps has been completed to deploy the cluster. So let me give the commands to you. from the starting to end. I think not required starting to end. There were
Ramesh,
some.
if you can share the document that you were following, that would be of great help to us.
Yeah. This document is already there, but anyway, I will give that again. No problem. It is there already on the portal.
Thank you, Ramesh.
Yeah, share it on this
From-
thing will be very important for us.
From step number 40.
And
Yes.
just to reiterate, that point where we had the error of port 8080, thank you, Ramesh. That's where I always had my problem, and I had to delete all my Azure machines just because of that problem. Thank you for explaining to create the directory and all of that. Yeah.
Yeah, thank you. Okay. All right, guys. So now I'll come to the DNS also. Just I have that in my mind. Just give me 1 second. Piyush, is it a time for the break, or do you need to wait for some more time? Because I need little bit 5 minutes break at least. So once we come back, then if you have any architecture or installation related questions, guys, I will take that questions. Don't worry about it. Is that okay?
Yeah.
Sure.
Okay. Yeah. Yes.
Let me take a break for 5 minutes. So you can
Ramesh,
have a counterpart. Yeah.
in the meanwhile, can you show us the web page where all this documentation is available?
Okay. Let me come back if you don't mind. I need a break. Okay.
Okay,
Yeah,
no problem. Thank you.
Thank you.
This conference will now be recorded.
All right, friends. So let me show you the documentation which is required on the Kubernetes IO. Okay, and here you can find out this documentation. And here it is. They have given the steps: set up Kubernetes cluster with KubeADM setup tool. So when you are trying with the KubeADM, you require minimum 1 master node and 2 worker nodes. Okay, and if you are trying it on some other machine, and if you are trying it on some other configurations, okay, then you can use. There are one configuration is there which you can use only single machine as well to deploy it, right? But we are using this KubeADM. Look at this. So here you can find out all the steps. This is what I wanted to tell you. So all the steps which I have fired, look at this. These are the commands which I have taken. You can see this, right? Okay, and now these are the network plugins requirement given, and these are the number of ports. If you want to keep your firewall on and running, make sure that you open these ports. These are the ports required. On the worker nodes, these are the ports required. So this is for just information, guys. Okay, and now if you want to install on the Linux machine, you can install as well. These are the steps given. So look at this. This is for Debian based distribution. This is for Red Hat based distribution. And if at all you want to do it on some other without a package manager, also you can do it. Okay, so let me go back again. So if you want to install the Docker node, if you want to install KubeADM, Kubelet, and kubectl, these are the steps given. So you don't have to remember anything. Everything is given properly on this machine here. Okay, you can also use a configuration file. You can also use various YAML file configuration also to set up the automatic installation. You don't have to do. See, basically the way we do it on the EKS or on the Azure, we can do the same thing from our on-premises cluster as well. You can have the package manager, okay, and by using the package manager, you can deploy this on the cluster as well. So all the steps are given, guys, properly here. And if you want to see the network plugins which you have used, like CNI, okay, so these are the different plugins available. So you can go to the CNI specification, or just wait, let me show you here somewhere, it will be there. Network plugins. This is the container network interfaces. Yeah, and they have given, this is coming to the GitHub also, but actually this is for Calico project, this is for Vue project, this is for Selenium, this is for Multus. These are the different third-party plugins are available. Out of that, I have used Vue network, multi-host Docker network. Okay. Now, I hope that the documentation part is clear to you now. Another important thing is that you can use any cloud support. You can use AWS, you can use Azure, you can use your Oracle, virtual Oracle, you can use IBM Cloud, you can use any cloud, you can use OpenStack also. All that clouds platform you can use, the steps remain same. You don't have to do anything else. Once the systems are ready, once your via virtual machines are ready, the same steps are followed there as well, right? So for the one node cluster, you can use Minikube. You can, developers can use it, right? Testers can use it. For if you have the resource crunches are there, you can deploy Minikube and you can work on it. Okay, so this is one CNI link. Let me share this link with you guys. Okay. Now specific, there are a lot of questions has been asked in the chat box. So I try to answer, I will try to answer as many as possible. Let's see that. Why there are so many master and worker nodes in the kubectl, kubectl get pods, all namespaces? No, these are the, Sonali, these are the pods which are required. Do you know, as per the architecture, Sonali, we have seen in the master node, what are the things are required? In the master node, you required API server, you required controller manager, you required scheduler, you required etcd. So what is this? What all these are? All these are the pods. All these are the some YAML configuration files, and inside that configuration file, inside this pod, this images and containers has been kept, and that containers are nothing but that pods which you saw on the inside the all namespaces.
Okay, so it gives you like many master mapped to many master nodes and the worker nodes separately. Also.
Right. So basically, whatever the software is required to run your master and worker node, all of them get created on the master node itself, but they get deployed on master as well as worker node, which can be viewed by using these commands from the central location.
Okay, got it.
Okay, thank you.
And what is that kubectl init command that you used? What did it initialize basically?
No, that is not a kubectl init command. It is a kubeadm init.
Oh, kubeadm init. Okay.
This kubeadm init command broadcast basically bootstrap your cluster. It starts your cluster.
Okay.
Yeah. Pujita, you have asked me how to check ANI, any CNI is installed or not. You can use this kubeadm pod command. I think I have answered that question. Okay. Do you have UI to check all status of nodes and pods? Guys, you can install Kubernetes UI, GUI, okay, to access the portal. If you want to see it graphically, there is a web GUI also you can install. Okay. Sonali, I think that is clear to you right now. Sumanto is asking how to know which container is running in which pod. Okay, that I will show you. That I will show you. Don't worry. That is, we have to describe the pod, then we will be able to see which container is running inside the pod. That I will show you. Santosh, don't remember all these commands, right? It is there on the link, right? So don't remember. Just what you need to know that how to search it. If you understand that key points, how to search it, then don't remember the command. It is not possible to remember all.
Yes, but Ramesh, for the exam purpose, like how will we give the exam if we do not know the command or we do not know how to perform it?
No, once
Yeah,
you have to do
correct,
the
Ramesh. Same question.
once you have to do it, couple of times you need to perform on your machines. Once you perform it, then you will come to know on which page, on which link this page is there. Then you have to just copy and paste in the exam. If you blindly go on the exam, then you will not be able to remember. What I'm saying, don't remember the commands. Practice it couple of times. Automatically, you will understand where that pages is there. Don't worry. It will come to know to you. It is not that difficult for what you think. It is very easy, very easy. This Kubernetes is really easy. So you'll be telling me after 4 sessions on
But
later on. Mhm. Anything that you want to say?
yeah, Ramesh, but
Yeah, go ahead. Go ahead.
yeah, Ramesh, do we do miss in the exam, miss do we have any kind of miss like reference link that we can refer in the exam, or only they will provide a ready environment, right? And we to install the
Here,
all
if
this
you want the
setup.
documentation to be referred, you can use the kubernetes.io over there. You can open that link. Entire documentation of the Kubernetes is available for you.
But in the exam, it is allowed. So that's what I'm asking.
In the exam, it is allowed. That is what I'm saying. Is that clear, Santosh? Yeah.
Yeah, Ramesh. So one thing. So in exam only. So do we need to like create the VMs on any cloud, or VMs will be already provided? Or I mean to say, nodes will be already provided. So you just need to let the nodes communicate.
Can we just park this question for some time, if you
Sure,
don't
sure.
mind? Yeah, we have a preparation video also how to face for the examination. Okay, we can do that. Let me cover this one, please. Please move. I don't know what is it. Santosh is asking. What does kubectl? Yeah, that is also clear now. Can you? Abhiram is asking. Can you explain how many static pods and purpose of each, and system pod with respect to master and system pod with respect to worker and purpose? Okay, Abhiram, I will definitely explain you this one. Okay, so what is trying to ask me the question that what is the purpose of each one? So kubectl gate pods, but I think by this time I think I hope that your question is answered. But anyway, so purpose of the pod as per the architecture discussed, Abhiram. So ViewNet is for the CNI, which will communicate, which will have the communication, which will keep the communication on between all the nodes. Scheduler is used for finding out the right healthy pod, healthy worker node, and deploy that on the healthy worker node. Kubeproxy is used for the service creation and IP creation for the pods. This controller manager is something like that required for maintaining the replication controller, replicas and everything, deployment, replicas controller, namespace controller, and a lot of things are there. Then this is API server to which we talk to, developer will talk to, and it is available only on the master node. This is wherever you see 111, core DNS is applied when you have a host name of the container or pod name. If you want to convert that into IP address and IP to the name, that time you require a DNS services. And etcd master is the only one pod that is available. I can replicate this pod, guys, if you want. If you want this pods to be 5 times, I can make it. If you want this 5 times, I can make it. I'll show you that how to do that today, if the time permits. Otherwise, in the next session, definitely I'll show you that how I can make sure that I can replicate this pod for the 10, 5. So automatically it's what do you say? HA is maintained. Okay. So if it is a static pod, then we will not be able to do. But if it is a dynamic pods or if it is a deployment, then we will be able to do. Otherwise, static pods cannot be replicated. Please keep that in mind. So not all the pods are static here. Some of them are deployments. Abhiram, is that okay?
Yeah, the static pod, when you say I'm not sure, like, how do you differentiate static versus dynamic?
That I will explain you in when we deploy the pods in some time.
So here, looking at the naming, I cannot find out which is static and which is deployment, or?
So there is a command called as a kubectl get deployment. If you are able to see the deployment, then they are not static pods, they are dynamic pods. They can be scaled out and scaled down. But if you see, if you just see if you fire the command kubectl get pods, and if they are not part of the deployment, they are the static pods. That is the way you have to differentiate. But if you are not clear what I'm saying right now, please hold this question for some more time. I'm going to discuss about the static pods in detail. Nilesh, you are asking that, please type. Okay, thank you.
Ramesh, same question. Code DNS, what is that?
The job of the DNS is to convert the host name into IP addresses and IP addresses into host name. Okay, so wherever you are using a host name, okay, you need to convert that back into the IP addresses, and that job is done by using the DNS services. So there is a possibility that you may use a host name to communicate, or you may use IP addresses to communicate. Then there should be a conversion parameter, and that is done by using the DNS. So if you type www.yahoo.com, because computer doesn't understand www.yahoo.com in general way, I'm telling you, it understands the IP addresses and then zeros and ones. So to convert from the yahoo.com to IP address, you need to use DNS services. So same thing here also.
Got it. Thank you.
Thank you.
Ramesh,
yeah, getting me?
I mean, is it possible to connect to the worker nodes from the master node?
Yes.
And perform all the actions, because every time you don't have to log into worker node to execute some commands, right? You can perform that from the master node.
Yeah, if you want, if you are talking about the installation process, and if you are well versed with the SSH, it's fine, you can use SSH from the worker master node. But if you are talking about the Kubernetes cluster deployment, workload deployment, then you can use the second. Now, yeah, what was your question? I just forgot that question.
No, yeah. So my question was, I mean, can we so when it comes to installation, okay, and setting up cluster, okay, I can understand. We can log into master node and multiple worker nodes and do that. Okay, but once the whole setup is ready, the environment is ready to go. Okay, just for managing purposes, okay, we don't have to log into worker nodes, right? We can manage that from master node, right?
Yes, correct. Your understanding is absolutely correct.
Okay, thank you. I am a little bit confused about this wave command, what it does actually, and because somebody earlier said that there are multiple options also available, so I'm not familiar with that. What exactly it does?
Yeah, see this diagram, architecture diagram. There are pods inside one worker node.
Right.
So if the pods are there, the intercommunication networking, okay, and making them available outside is the job of the kube proxy.
Okay.
So networking part of in the worker node and outside the worker node is taken by the kube proxy. But what is the CNI plugin is required? CNI plugin is required to make sure that the master node, worker nodes, and worker nodes are communicating with each other. How API server will talk to the kubelet? There should be some networking from this one to this one. There should be some protocol should be to talk from API server to this kubelet, and across cluster communication is maintained by the CNI, but the communication inside the worker node is maintained by the kube proxy. So there are
Okay.
different flavors are there. You can use CNI, you can use Calico or something like that. There are multiple flavors which are plugins are there which you can use. It should be
But
compatible with the
Ramesh,
container version. Mm-hmm.
this is Vivek.
Yeah, Vivek.
So CNI is only when you have your own. I mean, it's not a managed services, right? Once we have control, I mean, there's an option, but if we are deploying this in cloud, let's say, right? In that case, we can use, let's say, Azure networking, or maybe AWS networking. We don't need to use WaveNet or Calico or other DNS or networking option, right? They already have those kind of networking or DNS components.
No, if you are using their setup like Azure cluster, Azure Kubernetes cluster and Azure's cluster, right? If you are AWS cluster, if you are using, then we don't have to use it because they take care of it. But if you are deploying on the virtual machines, then you have to use it separately. Then you don't have, you can't use their network. I mean,
Why? I mean, I thought that I understand what you're saying. If just like you have done this right in Azure, right? You have created one master node and master server and two worker node, right? The same thing which is on-prem or Azure doesn't matter because it's your environment. It's not a managed services, correct?
Right,
So
right.
in that case also, if you deploy this infrastructure in cloud, the VMs which you deployed right now, in that case, there's an option available because since it's a cloud environment, right? So cloud will be give you more options like load balancers, auto scaling, and DNS. So those services we can still attach to these VMs, right? Or associate these services, those cloud services to these VMs to use it.
Yes, we can attach that services, not an issue. We can use a load balancer and all other stuff. What I was trying to say that we were discussing about the CNI. So if you are using the cloud enterprise level cloud solution from the Azure and AWS, they themselves take care of the CNI plugin. But if you are individually installing like me, then we have to use this CNI. I have used this CNI called as a view, but you can use any one of them. It should be compatible with your environmental Docker engine and everything.
Okay. Thank you.
So
Yeah.
Ramesh, sorry to pitch in. It's related to this only. So can I ask the question? CNI.
Yeah, please.
I have actually posted a question, but since you are just highlighting. So my question is like any recommendation which CNI to use? Like suppose before going for this designing and all, we need to have a technical design document which will be presenting to the client. So what sort of a CNI we should recommend to the client? Like now we have used Vue, Calico, Alico, something else also there, right? Calico. So what we should suggest to a client? Like I don't know.
Okay, so designing part, actually we will discuss about that, but this website, this link will be helpful to you rather right now. Why I'm using a Vue network? Because it is a multi-host Docker network. It is powerful for that, right? And if you have anything else other than the enterprise IP address management for containers, you can use this one. If you want to use multiple LAN cards inside the containers, if you have multiple LAN cards inside the container, then this particular plugin is absolutely fantastic. So we need to study, we need to understand it.
Got it.
Yeah.
And one more related to this one, like since we have used a joint command, right, to run on both the worker node.
Correct.
Okay.
Yeah.
So what difference does it make? Because anyway, like joining is nothing but to have a handshake with both the worker node, and CNI also do the same thing. I'm not able to understand, like if you are using the join, then why we are using that CNI?
No, join command is just to find out which master node it has to join.
Okay, so it's like a relation between master and slaves. Like, okay, this slaves belong to this master. Is it like that?
Right. You see this now. This is the IP address we have used of the master node. This is the port number, and on which token you have to connect. So that is the only information given.
Okay.
Ramesh.
So okay, got it now. Yeah, thank you very much.
Yeah, Ramesh. Hi, can you go back to the schema, the architecture schema, please? Sorry,
Yeah.
there is noise around me. Why we? I posed the question before. Why we don't see the kubelet in master node? Because when we install we install the kubelet in the master too. Why in this schema we don't have a kubelet?
You should have it. See, this kube proxy is also there in the master node. It is not highlighted. You have a kubelet, C advisor, whatever you see on the worker node, it is there inside this one. But only things that
Not all, I think, not all. Something. Yeah, this C advisor too, because it's
it is there.
integrated with the kubelet, kube proxy too. We have it in the master.
Yes, we have.
And
we have kube proxy.
Yeah, one other question, please. Now we install all things, but sometimes the VM we are a free account, and for in my side I have still have just eight days to work with this account. Is there any automatic way to install this all thing without going create a new account, install create the tree VM, make the connection between, install Docker and Kubernetes? Is there any automatic way to do it?
Yeah, you can use Vagrant. That is also available. You can use Helm chart. They are already available. That steps are available. They will create the VM as well as deploy this.
Can you please, if you have a link to help us to
Sure.
Yeah, thank you.
Piyush, can you just remind me about this link? We will create this link and we'll provide this link.
And I have a question. Sorry, I have a question again about in development mode. I heard about Minikube. Do you have any idea? Did you use it to see to know if it's easy to install it and to manage it?
It is a one node cluster, Minikube. We can use basically to deploy and see environment. I don't see that is used for the production, because it is just for the testing purpose or just practice purpose. You can use on the one node.
Yeah, I'm talking about just development in development mode. In production, I think you have to install master or several master and worker too. But in development mode, we need to work with Kubernetes, and sometimes we don't have space to install all this machine in one machine.
Yeah, that tool is there. It is available. So you want me to provide you the link also for that?
If it's possible, but the most important for me, it's the automatic way to do all this stuff.
Thank you. Point taken, Jim. But please note down this one, Ayush or Piyush, please note down this one so that I can work out on it. I will provide the link to you. Okay.
So Ramesh, I have a question with what Hikam said, that if there is an automatic way of installing things rather than logging into master node and worker nodes and all. So I mean, and you said it is, yes, it is available. So what does that mean? That if you run, I mean, it can be some kind of utility or some tool, okay, where everything will be automated. You don't have to execute any.
No, what I can do, these are the set of the commands. I can write in one shell script. I can make it executable and I can give it to you.
Okay.
That is one thing. Another thing is that what he was asking, that he don't want to create the VM also. So your script should create the VM as well.
Okay.
So there are certain steps from the command line which you can fire to create with the help of Terraform also you can create, or with the help of just CLI of the AWS or other commands also you can use to create the virtual machine. So that is possible, he was talking about. So he wants end-to-end solution for the deployment of the Kubernetes cluster inside the Azure or AWS or maybe some other cluster.
Yeah, Ramesh, this is Vivek. I think that might be a good idea. How to automate with a Terraform or a script wise.
I will provide you the link, guys. Don't worry. But it is important. Don't jump to directly to the automation. First of all, by
Correct,
your
correct.
own hands, at least try it for 3 to 4 times how to deploy the cluster in the some location. Try it in the Azure, try it in the AWS, try it on your laptop also. Okay, because deploy. Okay, so have on-premises deployment, guys. You will learn a lot than the Azure and AWS. Okay.
Okay.
Yeah, please mute, guys. Please, it is making a lot of noise. Yeah.
Ramesh, Kamlesh here.
Mhm.
You said that there are multiple CNIs like Weave and multi something you showed that is for
Mhm.
multiple Docker instance or multiple Docker. So is there any problem in having multiple DNS this thing pods installed? Will that be beneficial just to avoid any last moment surprises?
So it is you can have multiple DNS pods here. You can deploy. You can deploy. There is no problem. But do not mix it. Okay, do not mix the flavors of the CNIs. It may
Okay,
not work.
okay,
It may not work.
okay, okay. And in case we face any issues after installing core DNS or something, how do we check the logs and all that?
That I will show you. Just wait. Okay. How
Okay,
to check the
Ramesh.
logs, that will see that. Linto is asking, this is the most important step to move ahead with the Kubernetes practice. Thank you for adding steps and sharing. Can we set up Kubernetes cluster? Yeah, Linto, that we can do it. Is there any question that I have not answered, guys? Anybody's question I have not answered?
Yeah,
Yeah,
Ramesh.
Ramesh, can you just tell us why we have core DNS 2 times? We have WeaveNet for three times because it's three VM. Why core DNS is we have it just two times? Core DNS just in the worker side?
Yes, it is on the worker side.
Ramesh, this system pods, etc master, all these are system pod, right?
Correct. These are the all
And they are
system pods.
always into a default namespace called kubes-system.
Correct.
So
Yes.
my question is this: they should always be in a master node, or it can be also deployed or automatically, load balancing to a worker node as well, right?
Yeah, you
So
can see they
who
are
is
already
doing
there.
this? Or we can do, right? We can do it myself also, customize. Okay, I need to deploy this kube system nodes or pods into a particular worker node. Okay, I don't want to be restrict this to worker 1. Maybe I just want to deploy everything in worker 2.
See,
Customization can be
basically,
possible, right?
yeah, it is possible. It is possible. It is possible.
Okay, maybe
How
I'm
to do
asking a lot
that?
of advanced question. Sorry, but
How
yes, you maybe go with
to
your own.
yeah, how to do that? That I will show you later on. But you
No,
can
no
do that.
problem, no problem. Sorry, I'm sorry to disturb you, but just continue with this. Maybe we can ask later on questions.
Sure. No problem. Thank you for that.
This is Anuj here, and slightly off topic. As you know, Kubernetes is actually moving away from Dockers from 1.20 onwards. So what are your views on this in terms of learning curve and systems already in production and CKD?
Okay. So
Pick it up anytime you think it's the appropriate time. If you think this is not the right time to pick it up, it's just to remind you that this is one of the
yeah, I know that this question asked in the last session also.
Right.
If I'm not wrong, because this question was there. I wanted to answer this question, but since there are a lot of things are going on here, I just want to hold for that one. Don't worry. But Piyush, please note down this question. If I need to answer this question.
Ramesh, other question, and sorry again the noise around me. Is there any web interface GUI to see what is running on, what is not running? For lot of software, sometimes we have interface web to manage this. It's easy to see that this okay. Okay, thanks. How to run it? There is a like a URL and the
It is very simple actually.
yeah, sorry Ramesh. Can you send it by
Right away,
chat?
right away.
Sorry Ramesh.
No issues, no issues. Okay. Yeah. But this is a very interesting, I think, this web UI. But try to learn from the command line. Then later on, you start working on this one. Right now, don't use. Once you understand the Kubernetes, then for the simplicity and for the better performance and for fast results, use this one. Don't use right away in the learning phase.
Ramesh, can you restart some services from the UI?
No, I think this is something which you need to, because I have not used this frequently. I always prefer to use
Command
only
line.
command
Oh,
line. Yeah,
got
I never installed also, once or twice only installed, but I never use this one. Okay, all right, guys. I hope that everybody has I have answered everybody's question, because not able to find out the sequence of the questions.
Ramesh, that CNI one posted, like CNI, you are telling communication in the architecture diagram, it's between worker, but you indicated it's across. So that should be across, right? I mean, that's what I was indicating.
Yeah,
So,
it is across. It is across. It is across.
oh,
It is
but in
not.
diagram it doesn't. So that's why I was confused. Okay, so it's between two worker, but you're telling between master to worker and other master to, I mean, master to worker is also the CNI should be there, right? Correct?
Correct.
Okay.
This is a view network. See here, these three pods get created, and one of them is on master, one of them is on worker 1 and worker 2 as well. So this is required on all. All right, guys. So I hope that you have understood the architecture, and this is actually a journey, guys. In one session, there is a possibility that you may not understand each and every aspect, but I'm damn sure that by the time we end up this sessions of the Kubernetes CKA training program, I'm damn sure that everyone will be comfortable with the architecture of the Kubernetes. So some things get clear sometime later as well. Don't be in a hurry, but make sure that don't miss the points as well. It is very important to understand each and every aspect. That is your right, and you should ask the question.
Ramesh.
Mm-hmm.
I understand that the master can manage the worker. It means that if you want to have, I don't know, to list the pod in the worker, you have to, or if you want to communicate, you communicate from master to worker. Is there any communication between the two workers, please?
So in the form of what communication in the pod networking, because everything is controlled from the master node in this case, right? But if you at all you want to have a communication, then one kubelet need to talk to another kubelet, or one proxy need to talk to the another proxies. So that is done by using the service abstract, the communication. Otherwise there is no way. Kubeprox. I hope that is clear.
Are you saying that if we deploy the pod using command line, and that into one worker node 1 and the other pod using command line on worker node 2, both cannot be able to communicate each other by default? We have to deploy by the service.
By default, they will be able to communicate with each other, because there is a CNI as well as proxies there. All the pods from all the worker nodes talk to each other.
But we go through master in each time to create, like, for example, if you create the pod in the worker 1 or worker 2, we have to go through the master first.
Yeah, basically I don't know the question which is there, that can some services from this worker node will talk to worker 2? That is the question, and I'm trying to answer that question. The communication is there, communication can happen, right? Because the networking services are there, right? But it is not advisable to use the worker nodes to deploy anything, and it is not useful also. But from the backend draws, if you want to use it, that is a different story as an administrator level, but do not do that.
I think question is this, that maybe I'm wrong, but I'm trying to, let me rephrase the question what the gentleman is asking. He's asking that do we need to connect to master server to deploy any pods through API? API server is a part of component of master server, correct? And that doesn't mean that it has to be in a master server. It can be in any of the node or worker node also as well, right? Correct me if I'm wrong. Second thing is we are not connected to master server, we are connected to API server.
Correct. So the API, yeah, that is correct actually. Your understanding is absolutely correct. You have to, if you want to deploy any payload, you have to go through the API server only, and API server is the one of the pod inside the master node. You cannot directly talk to the controller manager or scheduler or etcd. We have to talk to the API server to deploy it. I hope that is your question.
Ramesh, API server is a part of master node, correct? But that doesn't mean that that API server has to be in master node. It can be deployed, or it can be this is a system namespace, right? So it can be at anywhere. It can be in worker node also as well.
No, I don't think. I don't think. No, I don't think API server is in is all time in the master node. But my question is, can we deploy a pod just or create a container directly in the worker node without going through the master node? Is this possible?
You should have a kubectl and kubelet command running in that one. We will try that, Hicham. That is something which is, I have a kubelet command here. Okay, I'm so sorry, and I have a kubectl command also. We'll see that if it is possible. Okay, right now I don't think so that is right advisable, but if you have kubelet, because kubelet is the one thing which creates the pod inside the worker node, right? So if you have that kubelet, but I need to check out whether the API server supports that pod creation if the kubelet is creating that alone. Okay, because that data will not be gone back to the etcd to store that one. So that how to create that is different story, but that is not advisable. That is another thing. Okay, let's see that we are talking about the pod creation, pod, everything is there. How to do that? How to create it? Okay, Hicham, we'll come back to that one. It is a very good question actually. So how to create these pods, guys? And where they get deployed? How did it get deployed? How the pod looks like? We'll see that. So first of all, what we have done, guys, here, we have deployed the, now just focus, guys, on this part. We have this master node, and behind this master node, there are two worker nodes, worker 1 and worker 2. This is worker 1, this is worker 2, and this is my master node. And from API server, I will give the instructions to the API server that how to provide the instruction to the API server. Either I can use YAML file, that is called as declarative way to write a pod definition, or other way is that I can use imperative way, that is called as a kubectl command. So we can use kubectl command to create the pods. We can use kubectl command, kubectl, guys, or I can use YAML files to deploy the deployments inside this one. So kubectl command will talk to the API server, and then it will do the further things. Okay, but from this master server, which is a Linux machine, how we can communicate to the API server? And for that purpose, we have done that configuration copy file. Do you remember that, guys? I fired one command called as a cp etc/kubernetes/admin.conf to the root.kube.admin config file. So that configuration file has the credentials to connect to the API server. So if that is not there, you will not be able to connect to the Kubernetes API server. So let me show you how to watch this config file, and then we'll go ahead to create the pods. So if you want to watch the configuration file, you can use command kubectl config view. So here now our journey of the kubectl is started. So kubectl command is used to view all the resources inside the cluster. kubeadm command is used once to initiate the cluster. But if something goes wrong, you can also use kubeadm reset command if you want to remove something from the cluster as well. That I will show you some little bit later on. But kubectl command is now, if you want to talk to the API server, you have to use kubectl command, either imperative way or declarative way. So now I am showing you that how you can, the master server of this particular Linux box is talking to the Kubernetes cluster. So this is the information. You can find out the configuration view of it. So don't think about this, what is this certificate and all that. Only think about that this is the server which you are talking to. This is your API server. Your API server talks to is available on the port number 6443 of this node. And the name of the cluster which you are using is Kubernetes. And the name of the user which you are using is Kubernetes-admin. So we are connecting to this API server by using Kubernetes-admin user on this IP address and this port. The rest of the things will not discuss right now. We'll discuss in the another lecture that is called as Kubernetes RBAC and everything. In that session, we'll discuss about that in detail. Because of this, we are able to we are able to connect to the API server. So please keep this in mind. When I am firing this command kubectl get config or get nodes, why this command is running? Because of this configuration file. And where is that configuration file available? It is available inside root.kube config. And where is the standard file of it available? It is available inside, main file is available inside etc kubernetes admin.conf. This is the main configuration file. Once your cluster is up, once you have created all the users and passwords and everything, and along with the proper RBAC, make sure that you delete this or move at a safer location. Never ever keep this file in the Kubernetes cluster. You might have heard about there are Kubernetes master or jump server has been hacked. It is hacked because this information is leaked. You need to remove from this place. Okay, but don't delete it. Keep it at the safer location. Is that clear? Now, let's move ahead. So how do I create a pods, resources? So this is a basic building block of the Kubernetes. So guys, and where I should create it? So inside the cluster, please create your namespace. So namespace is a logical entity where we can group all the resources in that namespace. Another important statement I am making here, the namespace is spread across the cluster. If I am creating this particular namespace on this master node, but it gets created across the cluster, the resources inside that gets created across the cluster. And how to create that namespace? You can use this command kubectl create namespace called as, let's say I will use as a K21 right now. So it shows that K21 namespace has been created. If you want to know something more about this namespace called as a K21, how do you go? How you get that? You can use that command kubectl again. Describe. I can use a shortcut called as ns K21, and you will be able to see some information about this one right now. That what is the name of it? We don't have specified any label, annotation, and status. Status is active, but there is no label and annotation given. What is label? What is annotation? We'll discuss about that. There is no resource code applied. There is no limit range specified here. This is the information about this namespace.
Ramesh.
Now,
Ramesh, sorry to interrupt you. I wasn't in the beginning of the session, but did you explain what is the pod, what is the namespace, please?
I have explained them about the pod.
Okay, sorry.
I'm discussing about the namespace right now. Okay, and we are going to discuss about the pod now. That is what our journey is altogether. So now I want to create a pod. So what I'm going to do, there are two ways I told you that. One way is by using a command line, and another one is by using a YAML file. So when you use a command line to create a pod, that is called as the imperative way. And when you use a YAML configuration file, that is also called as a manifest. YAML deployment configuration, a lot of words are used. That is called as a declarative way. So I will show you now how to create the pod in both ways. So pod is nothing but a logical unit which contains the container. Why pod is there? Because it can hold multiple containers. That is a Kubernetes way of definition of the pod. So let me create it. So if you want to create a pod, you need a container inside that. So of course you require an image. So you need to define the image as well. So kubectl run. This is the command which is used to create a pod. And I will give the name of the pod called as, let's say, pod 1. Which image you want to use? I want to use image called as Nginx. And which namespace you want to create? I want to create this in a namespace which I have created called as a K21. So this K21 is a namespace. And so this pod will get created inside the namespace called as a K21. Let me deploy it here. And it is created. How to see the more information about this K2? How to see the more information about this particular pod? So it is seen by using kubectl get pods from the namespace called as K21. And can you see this is showing pod 1 is right now running, and it is running start from the 23 seconds back. If I don't use the namespace here, will I get the pod? No. So what is the guy's namespace? Namespace is nothing but this is a logical space which can hold different resources such as pod, such as your resource quotas, such as your let's say what do you say, deployments, such as your replica sets, and so many. So this namespace, it is a logical grouping of the resources. So in case I want to delete all the resources, what I can do, I can just delete the namespace. I don't have to delete these individual units or resources which are present in the namespace. So namespace is nothing like creating a resource group in the Azure machine. Azure, right? You create a resource group, and inside that resource group, you create a VM, you create a disk, you create a network. Everything is grouped together, and then it is called as the resource group. It is the same thing in the Kubernetes also. It is a logical entity which holds the different resources. That is nothing but a namespace. Okay, so what are the different namespaces are available in the Kubernetes cluster right now? You can see these are there. Default is there. By default, default is there. This is for kube node, kube public, kube system. These are the system level, Kubernetes cluster level namespaces are there. And this is just I have created as a customized way. Whenever you are not specifying any namespace, by default it will use. But I have a habit of creating my own namespaces and create the resources inside that. I can create a namespace called as a production. I can create a namespace called as development. I can create a namespace called as testing. And all the resources required for the production, I will keep in the production. All the resources required in the development, I will keep in the development namespace. It is just name of the group, nothing else.
Safely assuming you can delete the default namespace and reinitiate it each time.
Don't do that one. Basically default, yeah, that you can do. That you can do, yes. But that's why I always create something different and delete that one.
right?
Yeah. All right, guys. Now, so this pod is created, guys. See, and if I use kubectl get pods command, I'm not getting in the default namespace. I can set up this default namespace also to my namespace as well. If I want to create a pods every time in my namespace, why should I always use this -n option? How to set up the default namespace, I will tell you guys in some time. Don't worry. So this is the first pod I have created called as K21. So the pod 1, and I want to know on which machine it has been, or on which worker node it has been deployed. I can use -o void. So you can see this is showing on worker 1, right? So these nominated node and readiness gates I will explain in this one. This is something related to tenting and draining and cordon of the nodes. In that time this is getting used. But right now, just think about up to the node. What is the meaning of this one? The pod is now having one container. Status is running. Status is running. Status is running. Right now, it is not in the restart mode. Age is 4 minutes and 3 seconds. Running on the worker 1. That is the meaning of it.
But how, when we create a pod 1, we didn't decide which worker 1, worker 2. Who decide this?
As earlier discussed about, while discussing about the architecture, guys, we have scheduler defines this one. Okay. Let me just let me complete this one, this particular topic, and then I will ask you to allow the question, because if a lot of questions comes in between, then it makes me difficult to explain the concept, if you don't mind. So scheduler decides on which worker node it has to be gone, right? By checking out the two parameters. One is its filter out the unhealthy worker nodes, and check which worker node has more resources. On that it decides. Okay. So I got the IP address of this particular pod, guys, right? Can you see? I can use curl command to check it. What is running inside there? I am getting the website out of it. So it is running fantastically. By the way, this pod is running on the worker 1, but I am hitting this command from the master node. I'm getting it, right? Now, so just note down this command. Which command? kubectl run this command. This command is used to create a pod. Let me show you one more command, one more exercise. kubectl run pod 2 -- image is equal to http in the namespace called as K21. This is the another way. So sorry, this is another example, not another way. Okay. Now if you check, there are two pods running, kubectl get pods -n K21. And now the stage is container creating. So it should run now. Now my both pods are running. And if you want to see on which worker nodes they are running, you can use -o void. And one pod is running on the worker 1, one pod is running on the worker 2. If you want to know more about these pods, you can describe them. So I can use command kubectl describe pod called as pod 1 from the namespace K21. So this will give you the entire information about that pod. Let me show you guys. So the pod, this is the command from which I have fired kubectl describe. What is the name of the pod? Pod 1. What is the namespace? K21. This is the priority 0. On which worker node it is running? It is running on the worker 1. And what is the IP address? 10. What is the label it has got? It has got the. So what is the label? We'll discuss about this, guys. Run is equal to pod 1. This labeling is very important, meaning annotation also we will discuss in some time. Status is running. And now see the IP address. And somebody asked me how to find out which container is running inside the pod. So this is the information about the containers. So inside the pod, this container ID is running. Image is Nginx. It is running right now, right? And all other information is
Ramesh,
present.
as we know
Yes,
that you told us that there's no container will not get an IP address, right? Will not only the pod will get an IP address, correct?
correct.
So
So it
it's a
is the
Docker
pod.
container, correct? So it's a Docker container, right? And the container ID is a Docker container ID. So if
ID,
we
right?
go into more deep dive, can you check that this Docker container ID has no IP associated with that? We can run the Docker command to get that more detail about the content about that ID to make sure that there's no IP address associated.
I need to go inside the worker one to do that one, right?
I want to
So
check that, yeah, because if that is a correct statement, that it should not get an IP.
yeah, okay, no problem. So see here now, and this is my Nginx pod, which is running. This is my container, right? Docker inspect grep-i. This is the way we have seen, right? There is no IP address.
Okay.
Okay.
Okay, good. Thank you.
All right, guys. So this command will help you to describe about.
Ramesh, can you go back to where you created the second port, please? I just need to get that that command where you create the second port of HTTP. Yeah.
You want
Thank
this
you.
command, right?
Yeah, that's correct. Yeah.
Let me paste in the chat box.
Ramesh, please paste all that history once.
Yeah, it is now pasted. Thank you, guys. All right.
Thanks, Ramesh.
So I have just shown you the two commands to create the pods, right? So these are simple. So I can create multiple. Same way I can write a number of commands to create the pods. But I want to show you a different way. I want to show you a declarative way. How I can create a pod using a declarative way. That means I want to create a YAML files. So let me create one directory called as all my YAMLs will be kept inside this one. So I am showing you how to create the pod. So this is my pod1.yaml. So pod1.yaml. Okay, pod1.yaml, enter. It is completely blank file, nothing is there inside it. Let's write the pod. So there are 4 important parameters need to be written, and always whenever you are writing the YAML file, you need to use this API version, kind, metadata, and specifications. That is called as a spec. Okay, so kind I'm going to create is a pod. So kind is an object inside the Kubernetes. You have multiple objects like deployment is there, right? So many things are there. Metadata is nothing but information about this pod. What information you want to give? I want to give the name to this pod as my pod 3. I want to label this pod. So I want to label this pod as, look, this pod is something related to environment called as development. I want to declare this env as, let's say, something called as, for my customer called as Google. Okay, I want to say something like that. This is my disk I am going to use. This here is my SSD inside this one. These are some labels which I can give. Okay, this is my region. This is getting deployed in the region called as US East 2, something like this. I can have hundreds of pods in one region. I can have hundreds of pods whose label is disk is equal to SSD. I can have pods which are having environment called as a Google. If I want to segregate them, if I want to perform some actions on these particular pods, which are from the region called as the US East 2, which are having a label called as a disk SSD, I can do that one. So label is very important parameter from that aspect. If you want to perform certain actions based on the labels, you can use these labels.
Ramesh, in that case, do we need to criteria will be matching all the labels when they are creating a pod in that case, or if we only one of the label match, it will go to create, or it has to match 100% all the labels?
Yeah, action will be taken based on one label also, if it is matched to one label as well. And also
So
I can use
here we have defined multiple labels, right? So all the action has to based on all the labels, because if we have a dev, but we have a Google, we have a dev, we have a AWS, both are different, right? So it will not going to match the label. It will only pick up that label which has dev and Google.
So let me restatement this one again. There might be hundreds of labels to one pod, but even if one label gets matched, action will be taken. Action will be performed. Namespace, let's say I want to use K21. Okay. So because I don't want to every time write that -n while doing that one, I can specify the namespace in this pod definition only. This is my labeling concept, right? So label is nothing but to identify certain object from the list of the objects. We can use this one. So I want to change the image of the pods whose label is disk is equal to SSD. I can do that. I want to shut down all the pods whose label is region is equal to US East 2. I can do that. So you have to be very careful while giving the action and while giving the labels also. It has a meaning. And another important thing is that annotations. Annotations are extra information about the object. So which image I have used in this one? Let's say I have used image called as Nginx version 11, something like that. So where this is deployed or this is used in the production called as, or customer called as Google. So if you want to specify additional information about the pod, you can use annotations. Image versions, disk versions, disk size, anything that you feel that I want to add, so that it will it will be helpful for you to recognize the pod and understand about that pod. So any additional information which give the information about the pod can be written inside the annotations. I can write multiple times also. I have something called as image version 1.4, something like that. But the probability takes only last one. So version 2. So I can say here, this is my image 1. This is my image 2. This is my image 3. And their respective versions I can give here, version 13, version 14, like this. So these are the annotations. Now, what is there in the specification? Specification, what pod contains is the specification. So these are the properties of the pods. Now I want to write the properties of the pod, one more property of the pod, and that is called as so in the specification region, what I want to do, I want to create a container or containers. I need to specify what type of the container I want to create. So let's write the list properties, array of it. If you are using a dash, it indicates it is an array name. Now, what name you want to give to the container? Let's say I want to give the name to the container as C1. Which image you want to use inside the container, called as, let's say, HTTPD. which ports you want to use in the container. So I can use container port 80. So if any other properties that you want to specify, these are the properties of the containers. So whatever you can define, volumes, ports, any other thing that you want to specify, you can specify here. So this pod will have this container called as C1. Inside image will be HTTPD and it will be running on the port number 80. It will have these annotations, it will have these labels, it will create in this namespace. Will have name called as a pod 3. Whatever the parameters you want to attach to the container, you can attach as a property of the container. All right, guys. So let me save this one. This is a simple definition of the pod. Let me save this. And now I want to apply it. I hope that if any error is there, it will definitely give you the error. Pod1.yaml. Yes, it has shown me the error because I have not set the API version. This is something interesting. What is API version? We are going to use the different API versions for the different pods, right? So I'm going to use V1 version for the API version V1, version 1 for creating the pod. So I will show you the list of the API version, guys. What is the meaning of the API version? When to use which version? What are its properties? What are its specifications? Everything I will show you. Try to understand how to create the pod down. So now if I deploy this by using this command, it will automatically get deployed inside the namespace called as K21 because I have specified that namespace inside the pod definition. Right, guys? So now let me see. If I just use command kubectl get pods, there is no pod running in the default namespace. But if I use the default namespace called as K21, so my port 3 gets started now. It is running here. But where it is running, if you want to find out, using command called as -o white, and it shows that pod 3 is running on worker 1. And if you describe more about this pod 3 worker node, you will get all the information about the container. So kubectl describe pod 3 from namespace called as K21. And you can see here, guys, it is showing all the logs here, what has happened, right? And it is showing here something called as which container is there. This is a container C1. This is showing me the image called as HTTPD, which is running on the port number 80. And these are the labels which I have applied. These are the annotations available. This is the IP address I got. So this is the way we can describe the information about it, about the token.
Ramesh.
About the
That's the IP address of the pod, right?
Correct. Yeah, it is IP address of the pod.
Yeah, and also, so we can run the kubectl apply command on the same YAML file to build a number of pods, right? It is not only the one set of pod or one pod.
If you use the command kubectl apply -f pod1.yaml, it will give me the error. Why? It is saying unchanged. It is not giving me the error, but it is saying unchanged. Because all the parameters are same. If at all you want to change something from the pod, you can use command kubectl edit pods. I can directly write here pod 3 from the namespace K21. I think I need to give the pod here. Pod. This resource type is pod. And now it is opening the entire YAML file. And if at all you want to change anything here, I can change here. I want to change the image of this pod guys. I want to make it here Nginx. Or maybe any image for that matter. And let me save this. It is edited. And now if you describe this, you will be able to see that now the new image has been come, and that is called as Nginx. And it is indeed change. If I use this command, curl command, to check the output of it, you will be see the Nginx image. And if I modify this image again, and if I put here pod 3 instead of this Nginx, if I use httpd, one second, please one second, httpd, save this. It has got modified, and if I use the curl command, I will get the which one? httpd image output.
So the IP address of the pod remain the same. Only thing, the container image or container is changed with the different image.
Correct.
No, my point was actually, it's not about like changing or editing something in the existing pod, but you have explained it. I got additional clarity. So my question was like, with the same YAML file, can I deploy one more pod? It will not happen, right? I should change something in that and run again.
I need to change this one. I need to make pod 4, and I need to change the container information here. I need to make it C2. If I use this much, if I change this much inside the pod, and if I deploy this kubectl apply command, it will create a new container.
Awesome, thanks.
Okay.
So the pod name and container name has to be changed.
Yes.
So if you can have multiple containers right in the pod, can you create one more container?
Here right now. You want me to create it right now?
Yeah, in the same YAML file, you can still add, right?
So I can do that. There is no problem. But then it will take a lot of other explanation need to be done. So
okay.
Sure, I have a side topic, so I will explain in that one.
Sure. Thank you.
Okay, any other question that is there, guys? What is the
Can we
name
not
for?
change just the pod name, not the container name? Isn't the container name kind of within the pod name? That there is no need to change the container name, Mr. Ryan.
Yeah, that's what my question was. Like, we can have a container, but the pod name can be different, right? We can create a pod from a same container.
Let's prove this one. There is no problem. kubectl apply -f, because container name gets attached to the pod name. It is created, and you have correctly pointed out. Thank you very much. I hope that it is running. Yes, it is working. Because whenever when the two containers names are same inside one worker node, let's say you don't change the container name, and if that pod is getting deployed on the same worker node, even that time also it will not get confused, because container name gets attached with the pod name. So whenever you see the docker ps command inside any worker 1 or worker 2, you will find the name like this one, Kubernetes pod 1, and inside that there is container name. So even if you have correctly said that even if you use a container name, same container name, it is not going to make any impact. Thank you for that clarification. Good, very good.
So summarize this, we just need to change the pod name. We don't need to change the container name, whether it's a C1, C2, doesn't matter. It's going to create us a different container automatically.
Yes.
So Ramesh, does that also depends on the worker node where it is executing? Because it can create a worker node pod name container like that.
No, that is what I explained. Whenever we create a pod, so how the container gets created? Pod 1, if it is the name is a pod 1, then it uses the container name. So even if you use the container name same, the pod name should be different. You cannot have same pod names.
Okay. Even though the worker thread is changing.
Yes. Correct.
Okay,
so
thank you.
Yeah.
Ramesh, can I ask a question?
Yes, please. Now I have stopped now. My today's topic is finished. You can ask me.
So the question is, like, suppose if you are creating a pod from any of the existing YAML file, say for example, this cube there's a pod 1.yaml, okay, and I'm trying to create a pod from this YAML file. I want to edit it. So the moment we edit, we see a lot of content in that, right? Manifest, like earlier you have shown us. So means like if I want to make some changes and create a different, means say for example, I want to save it as pod2.yaml. The manifest, the content remain the same, but I want to just change the pod name. So what all changes we need to apply on that? Because this manifest which we copy, it will be directly from the pod 1 to pod 2, and then we are just making it as a different pod from that.
So basically, when you type a edit command, it is not used for the copy.
Sorry, yeah, edit,
yeah. So now what you need to do, if you want to generate a YAML file, you can use this command, guys. kubectl run. So let's say that you want to create this one. Let's say you want to create a pod 11 number. What I can do, I can use command this output YAML. It will generate the different YAML file for you.
Correct.
Okay, save this YAML file and then you can modify at the respective places. Where to modify, we'll see that one. And then you can create a different pod. So you can create with the help of this command, you can create a different YAML file. So let me show you. Let me see if I have this command as a dry run. Pod 12. Yes, it is coming up, but it is actually what it is doing. It is showing me that it is creating a new pod as a dry run here. You can see here. So automatically the YAML file gets created. You don't have to remember the YAML file.
Okay, maybe like in the exam, suppose if there is a YAML file and if you want to modify for a quicker fix, this command we can use it, right?
Right. And you have a kubernetes.io file, the documentation also you can use that. From that also you can pick up that one. Yeah, but this is useful.
Ramesh, who is deciding this API version? I mean, how we know that which version we need to put?
I will explain in that session because it is defined by the Kubernetes standard documentation. So you can get it from the Kubernetes IO. You have to just type here google.com and Kubernetes, whatever that. API version. You'll get all the documentation there. Very big table is there. That I will show you in the next session, please, if you don't mind.
Okay, no problem.
Can you just paste the command, the above command, so that we don't forget the upper one which you have created here?
From 68, I guess.
From 68 you want?
Yeah.
Ramesh, the last command generates a YAML file. Will it have a name?
One second. Yeah, what is your question, please?
The last command you mentioned, it will generate a YAML file. So is it the name of the file name is YAML or?
No, it is a format in which it is printing.
So what is the name of the file then? How will will it be get created in the same?
No, you have to transfer this. Let's say your name is, what is your good name?
Oh, Padmashri. Padma.
Okay, so Padma, you have to use this command.
Okay, got it.
Yes,
Thank you.
Ramesh, are we going to still have this lab in Azure?
Yeah, this is lab in the Azure only.
So what you've done so far, you did it in Azure.
Your question is that if you don't do this in the Azure, that is what your question?
Yeah, no. What I'm asking, what we've been doing, what we did today, you did it in Azure or on Ubuntu machine itself?
I did it on the. We created 3 machines on the on the Azure, and with the Ubuntu machines we have deployed it. So it is altogether on the Azure only.
Yeah, but we didn't see how you created these machines.
Ramesh, this is same
I have
question
shown.
to me also.
Yeah.
Because
I didn't
what
see how
kind
you
of
created
ports
this
you have,
machine because I'm new with Azure. I don't know anything there.
what kind of ports you all use for this machines? How you are connected from master node to worker node, worker 1, worker 2. Azure.
Yeah, they were shown in the initial part of the session.
No, I
Hisham.
think they are asking about the question that, if I'm not wrong, they're asking that how you created these 3 machines and how you have you opened any ports for this, right? That is what you are asking.
Correct.
Yes.
Right. So I think Piyush, we have a documentation for this, right? Video also for this one. So you can use that video to how to create the virtual machines on the Azure and how to open all the ports of the machines. So basically it is there in the networking part of it. You have to go to this place and there is a security group is there and you have to apply it there.
Ramesh, the last command is not pasted over there. I think somehow it missed the EML one.
Ramesh, last maybe one question is still not clear. Maybe I have a little bit of clarification. Why that there is a need of pod? Why we cannot create directly a container using that? So if you can elaborate that 2-3 minutes, that will be good.
No, basically important thing to understand is here, I can use a container, right? But that is they have used the scenario for Docker, right? Docker has used that naming convention called as a container, but Kubernetes is using a naming convention called as a pod. Now, and another logic behind that one is that in the Kubernetes, inside the pod we can have 2 containers. So how you will group them together? Not only 2, I can have multiple containers also in one queue. So what kind of name you will give that to the group of the container? And the Kubernetes has come with the name called as a pod, nothing else. So all the fishes in one pod, I don't know why that word is coming from the pod, what is the general meaning of it, but the pod is nothing but group of something.
So tell me, so if we don't have pod, then what's the issue?
No, then
what things will be missing basically?
No, I need to go to the Kubernetes architect people to understand that why they have used this pod.
Because I think this is a solid interview question that if container is doing everything, then why you need a pod?
Ramesh, I think maybe correct me if I'm wrong. Maybe I can just, because it's a good brainstorming questions for the interview purpose. Yes, you're right. The gentleman who asked this, but my understanding is that why they brought the pod concept in Kubernetes is to have a loosely coupled that containers can be any engine. It can be Docker, it can be CRIO, or it can be Rocket, whatever is it. So they want to make sure that we are not having a dependency of any container. You can bring your own container engine, and pod will make sure that everything is act as per the application requirement.
Okay, just try to understand one thing, guys. You don't have to think about much about this point. To group the containers, pod has been created. Nothing else is there. There is no other logic behind this.
Can I just add one explanation? Basically, you're using Docker. Docker does not have replication, does not have, unless you use Docker Swarm, we decided to use Kubernetes. Kubernetes uses pods. So therefore you have to have the Docker containers within the pods so that Kubernetes can do the orchestration work. Otherwise, there's no point in having Kubernetes over there.
Right.
That's correct.
I mean, my 2 quick cents, from the question about why the need for a pod. No, I think it's a combination of what Ramesh mentioned during the session. One is about, I think the answer lies in a combination of what is a namespace and why we need a namespace. Pod is also in line with the namespace, logical resource management. There are some common set of resources that get shared within a namespace and similarly within a pod.
Yeah,
I think
Okay.
basically used for the
Just
replication
one.
cluster only.
Yeah, one quick one. I think containers. When you create a container, you cannot manage multiple containers or clusters with Docker, except you use Docker Swarm or something. And that's when Kubernetes come in with orchestration to be able to manage multiple containers and to be able to interconnect them to work together.
Yeah, correct.
If you allow me to speak, the central theme here is microservices. Your pod is a self-contained unit that contains all its necessary dependencies, and that is why from Lexi to Docker to pod, that is how it has been the generation after generation. So Lexi is the Linux containers, then it moved to containers itself. Containers itself are very dumb, and you have to bring them in a unit called pod and make sure that if there are any dependencies that it needs, or if there are any other microservice dependency it needs, it's all within the pod. Now, if you cannot do that, you can always have pod-to-pod communication. So from what I've read, that's the central theme around why the pod. But it's a progression from, it's a progression from Lexi. Go ahead, please. Yeah.
Yeah. So sorry to interrupt you. I have one more question because Ramesh said earlier that, let's say I have 3 containers inside a pod, okay, and individual containers won't be having in separate IP addresses. Rather, the pod will have a IP address, okay, and that IP address will be used for connecting to multiple containers inside that pod, right? So, right, Ramesh, or
yeah.
Yeah. So now the thing is that then how will you differentiate between the containers? Why? Because now I have one IP address for all the 3 containers. Okay. So, I mean, how the communication will happen between, yeah.
Okay. Now, okay, this is a very good question. We'll take in the next session, guys, because everybody should know, because most of them have left now because of the timing. And what we will do, we will create a multi-container pod. That time, I will show you how to log in this container, how to log in this container, how this container talks to this container. That we'll see that. There is no problem. This will get clear.
Ramesh, one more question. Do we have any document to implement this on our virtual box instead of the cloud one?
No, the same documentation is the same documentation you have to use. Same to same.
Because
no
you need to
changes.
disable the ports, right? I mean, to allow the systems to talk to each other, right?
No. Only thing is that only thing that you need to care. Only thing you need to care is that you have to stop the firewall and stop the SE Linux while creating it. That's it.
That's it. Okay. But the network, how do they talk to each other?
Yeah, Venkatesh, I mean, my personal experience is that, better you use Azure, okay? Why? Because if you are a Linux admin, okay, until unless you are a Linux admin, okay, you'll be having a number of challenges in configuring this, okay? So better to go with,
Hi, Sumant. I think I know. The other gentleman, you are right. You don't have to be a Linux admin to do this one on the VM. I think Ramesh is showing you that particular one. The only networking concept you need to understand is so long as you have the bridge network, you should be okay for communication. I don't know who asked the question. Ramesh, you can chime in on that particular one. for anybody who is not well versed with the networking, just to configure it as a bridge networking, and then it'll bounce off of your own internal router, and then you would be fine. And then so that's not an issue.
Yep. Yeah, I'm using the bridge network. Yeah, actually I wanted to try on it on a RHEL instead of Ubuntu, because anyways we are seeing the live sessions and we are practicing on Ubuntu, right? I wanted to take some hands-on on RHEL as well, because we use most of the systems we use in our organization are enterprise Linux and RHEL. We don't use Ubuntu much.
Right.
Yeah,
So long
but
as you have a good laptop, and then you can do this one n number of times, and then that's what I do. And then I kind of, I have a good laptop, so I just bring it up, down, and then the only time is, so long as you have time to invest in, then absolutely you can practice.
Yeah, I mostly use VirtualBox.
Yeah, Venkatesh, you are also right. You can use Azure VM for the RHEL flavor also.
Okay, Ramesh, how do we use copy and paste in our virtual machines?
You want copy paste these machines?
Yes,
Virtual machine. No.
Copy from our clipboard and paste in a virtual machine, like you copy a command from a URL and paste in your virtual box, like Linux.
So best way is best way is that access through the putty and do it. Don't try out that copy paste; it will not work.
Okay.
You have to. There is an option also, but in some places it doesn't work. Make sure that you access through putty and then try it.
By installation, you need to select the capture option. Apart from that, what you can do is, if you're using Mac, you can use the terminal.
Yeah, it doesn't work. I have seen that capture option. It doesn't work.
Ramesh,
guys?
Yeah, Ramesh, one question. Ramesh, that in pod, the YAML file, I was trying to differentiate between annotation and metadata. Can you just update that? I mean, I was confused there only.
Label is used for logic definition, that using a selector. If you want to do some perform action, you can use the labels. Annotation is just a metadata.
No. Metadata and annotation. No.
It is just additional information for the container or that pod, but that you cannot use for the taking any action. Labels are used to take the action.
Label are used to take action, but I was thinking instead of annotation, I can use metadata also, right? I mean, to give the additional information, no?
Metadata is the part of annotation is the part of the metadata only.
Oh, okay.
Ramesh, this is the what you are showing, that screen is your local machine?
Yeah, this is my local machine, and I normally teach from this local machine only, Kubernetes.
But Ramesh, why we are using annotation? I'm still confused a little bit. I mean, is it required, or is it something which we need to just to clarify why we have to use annotations?
No. If you want to give the descriptive information about any object, you have to use annotation. Right?
Any example?
Annotation. This is my image created on 19 February 2020, used for this production server. This comes as annotation. Okay. Label is just key and word format. There is a key and value is there. So
the way I understand annotation, the way I understand annotation is like a common section. That's it. That's all it is. So it provides additional information about something.
Yes, right. But which is not used as a logical, which we don't use for the any action purpose. It is just additional information about it.
Maybe just like a description.
Yeah, it is like description, right? Correct. Additional
and Ramesh, the way I understand it is both contain metadata, but one contains environment related metadata, and annotation is a more descriptive version. So say you had a metadata called version 1 or version 1.2, then I can add in annotation more about version 1.2, saying, hey, you know what, version 1.2 was deployed by Ramesh, something like that.
Right.
As an example. So that should be the subtle distinction between label and annotation. Both contain metadata for sure, and that's what's being called, right? I mean, to reference that pod or to direct instructions.
Amit, that is not the main distinction, Amit. I think Ramesh had pointed out that the label, you can control it. You can have, the other one is annotation, is description, and that's it. So that is in the label, for example, you can use it to select, and then you can have any of the things. So the label has got much broader, control, aspect of it. Annotation is, that's just remarks, comments, description.
Yeah, that's exactly what I'm meaning. That's what I'm saying. That it is a descriptor, more detailed descriptor. If you want to do that way,
Absolutely.
you can see that on you can see that
let's-
distinction clear on a K21 document. There's a K21 nice document out there.
Okay. So guys, if these are the 5 pods are there, like this one, these are the, let's say 4 pods are there, and all of them are labeled in the same way. Like there is a common label called as a disk is equal to SSD. And if I decide I want to delete the pods whose label is, and there is one more pod whose label is something different. Okay, so all of them are having a label called as SSD is equal to disk, and this label is having, let's say dish is equal to vada pav. So what will happen? This is a different label altogether. So when I fire the command that kubectl delete pods where the label name is equal to SSD is equal to disk type, what will happen? They will delete all these 4 pods, excluding this one. Right? That is the use of the label. And annotation is nothing but whatever the additional information you want to allow to describe that item, you can use that one as a annotation. So you can say that this is my image 5.6 created on this date. Okay, so this is the additional information that you are putting to that particular object to identify it. That's it.
And
All right,
Ramesh,
guys,
only one question. Ramesh, you used 2 type environment, right? I didn't catch that. One is environment was test and Google. What was that? I didn't catch that. What is that environment?
I just use randomly that one.
Environment should be only one, right? Or is it, or environment can be multiple, or?
No, key should be only one. Key should be one always. Value can be multiple.
Oh, so why value? Like one use give test and another was Google. Why is it value different? I mean, what is the purpose there in as an environment then, or it's a multiple environment?
Key is environment. Value is
don't catch me on that. Yeah, don't catch me on that particular environment is equal to Google and environment is equal to test. It can be considered that, oh, I have an environment for this project, but which is a test environment. I am working for the Google project, but in the test environment. I am using for the project called as a Google, but for the production environment. I can use any name which is as per the project stuff, right? So don't catch that as an env word, which is used inside the your what you say container as an environmental parameter. No, it is not like that. I have just used that env as a production or development. That is the meaning of it.
So even if you describe that, it will take the latest one, right? As it took Google. Yeah.
No, it will take latest one if you have the same keys.
Yeah, correct. So the gentleman, he pointed out like why dev and Google. So, but when we saw the describe part of that, we saw Google. So it took the latest one. It yeah. Okay. Thank you.
Yeah, chalo. Guys, it is already now we have crossed 30 minutes of time.
Ramesh, just remind you about the automatic way to run. You say the Vagrant, if you can in future, not today. Just to remind you, please.
I will try to do that. I should get only time. That's it, teacher. That is the only I'm not having.
Of course. In the future, not today, not tomorrow, perhaps, but in the future, if you.
But I will keep in my mind. No problem.
Okay, thanks.
Thanks, Ramesh, for the session. Have a good night.
Thank you, Ramesh. I think this is my first session. I like it.
Thank you very much.
Just want to appreciate you guys, and I think we have good team here again. Back Amit, Abhiram, and Ranjit, and Alagu. Everyone was there before also. I believe the last batch. There will be definitely a good discussion. I hope so.
Thank you, guys.
Thanks, Ramesh.
Thank you. Good night.
Good night. Thank you, guys. Take care of yourself. Bye.
Bye-bye.
Good night. Bye.